Hello and welcome to the complete JavaScript course. I'm really excited to have you in this massive course, and I promise you made the right choice by joining me in this adventure. Because today, JavaScript is not only the most popular programming language in the world, but it also powers the entire modern internet. Now, without further ado, I want to give you a quick overview of how this course is organized, the projects that we're going to code together, and also what exactly you're going to learn in this course. So the course contains a total of 8 sections with over 26 hours of content. So we're going to kick off the course in section 2 with the very basics of the JavaScript language and programming in general, to give you a solid foundation for the rest of the course. After that, we're going to take a look behind the scenes of JavaScript and learn how the language actually works. And this is going to be a good mix of theory and practical lectures designed to give you the knowledge that many other JavaScript beginners simply don't have. We then move on to our first project, where we use JavaScript in the browser for the very first time. And so we're going to code up this really cool game where we make JavaScript actually interact with an HTML web page. Alright, and after that, we're going to take a deep dive into the most advanced JavaScript concepts, and that's objects and functions. We're going to talk about things like prototypal inheritance, first-class functions, closures, and a lot more stuff. Next up, we put everything we learned up until this point together and code this beautiful budget app where we can track incomes and expenses and calculate the global budget for any given month. So in this project, you're going to learn tons of new stuff like how to structure and organize your code and how to actually think about problems and solutions. Then, starting from section number 7, we're going to start using next generation JavaScript. So ES6, ES7, and even some ES8 features. So we're going to start by looking at what's new in ES6 or ES 2015, and then code some examples with the new syntax. Next up, you're going to learn all about asynchronous JavaScript, which is used for things like loading data from external servers with Ajax. And then finally, to wrap up the course, this is the biggest project coded entirely in ES6, ES7, and even ES8. So we're fetching data from a real API here and building this real-world app around it, using the latest technologies and also tools like NPM, Babel, and Webpack. Now, in all of the videos, I always explain every single detail of the JavaScript language or of the technique that I'm using. But sometimes you may still have a question about one of the topics that you're learning in a particular video. Or maybe you just run into a problem with your code and need help fixing it. Well, either way, you can always get help here in the Udemy Q&A section. So at the bottom of the video that you're watching, you will always find the questions section for that specific video. So whenever you have a question, you can check if another student has already asked the same question before, and if not, well, you can just post your own. And you will then get friendly and fast support from me or from my team, so that you're back to writing code as fast as possible. So I hope you're going to have a ton of fun with the course, that you become a real advanced JavaScript developer, and that you will take your web development career to the next level. That's really all I want to achieve with this course. And with that being said, let's finally get started. Now, before we can actually start, we need to first set up the most important tool that we need for this course, and that is a code editor. So the code editor that I'm going to use in the first part of the course is called Brackets. Okay, so you can just go ahead to brackets.io and download this editor if you want to use the same editor that I'm using throughout the videos. Now, some people of course already have their editors installed, like VS Code, Sublime, or Atom, and if you already are set up with your own editor, then there's no need to install a new one, of course. You can just use what you already have. But if you're new to all this, then you can just go ahead and download Brackets. Then in the second part of the course, I'm actually going to use VS Code, simply because it was recorded at a later time. Alright, so this is what Brackets looks like, and that's because I have a theme installed. Okay, so let's take a look at the setup that I have for this editor, and you can take a look at that on the course GitHub repo. So in the last lecture, there's a link that points to this repo, and basically this repository contains everything that you need for the course. So all of the code, the final and the starter code, then the slides, so the entire slides for the course, and then also the setup. Okay, and down here then you also have the frequently asked questions. So before you post something to the Q&A, you can always take a look at these frequently asked questions first. Okay. Now, but to set up, I have a special document here because I get asked all the time what themes and what extensions I use. So for brackets that I use in the first part of the course, I have a theme called OSX style flatten dark. And then the most important extension is an autosave extension. So let's go ahead and set these up very quickly, just so that your editor looks the exact same as mine if you choose to use brackets. So just hit this icon here on the right side, which says Extension Manager, and then you can first hit Themes, and then OSX style, and here it is. Okay, and so all you need to do now is to click Install, and I already have it installed, so that's why I don't have a button here. Then you just close it, come here to the View in the menu, then Themes, and then you can select the OSX style theme from here. Click None, and now your code editor should look the same as mine. And then as for the other extension, just hit the Available, then Autosave, and the one that you want to install is this one, so Autosave Files on Window Blur. And so what this is going to do is that each time that we leave the Brackets app, it will automatically save the file that we're currently working on. Okay, so that is brackets. Then again, in the second part of the course, we're going to use VS Code here. So this code editor, but more about that by then. Okay, then down here you have also the theme and the extensions that I use in case that you're curious. Okay, and that is the setup about code editors. Now, of course, you also need a browser, and I'm always using the latest version of Google Chrome. And so I advise you to do the exact same. Then in the browser, what we're going to use a lot, especially in the beginning, is the developer console. And so let me quickly show you how you can use that. So you can come to the View menu, then Developer and JavaScript console. And then it will open up the DevTools, and you have the console down here. And you can also do it another way, which is simply right-click anywhere on the page, then hit Inspect, and then you can click Console over here. All right, and so in this console, we can very simply execute JavaScript commands, like math operations like this, or assigning values to variables, something like this, and then read them out. So this is just to execute JavaScript here, okay? But I'm already getting ahead of myself here, so I'm already writing some JavaScript code here, but let's leave that for the next section. All right, and I think we're actually ready here, and so let's now finally move on right to the next video and to the next section, where you're going to start learning JavaScript. Welcome to the first section of the course. And in this section, you're going to learn the very basics of the JavaScript language. Things like variables, data types, functions, objects, arrays, and many other things that are part of the JavaScript language. And the best part is that you're actually not just going to learn JavaScript itself, but at the same time, the fundamentals of programming in general. Now, later in the course, we're actually going to come back to many of these fundamentals, but for now, I just want you to get a quick overview of how the language works and get your hands dirty with some coding. So, this part of the course is really not about making things look pretty in a browser or anything like that. Right now, we just want to focus on the JavaScript language itself, and then the rest will come later. Alright, so let's go start this journey right now. Let's now actually write our very first line of JavaScript code. And here I am in my text editor brackets that we just set up in the last lecture. And I hope that you already downloaded the starter files from the course. I already have them here on my desktop. So it's in this folder here. And you see that here I have the index.html file. Okay. And so going back to the brackets text editor, all we have to do in order to start a new project is to hit this button here and then click Open Folder. And so the folder that I want as my project folder is this one here. Okay. And so now all I have to do is to hit Open. And so this is now the project folder, and it opened here this this index.html file. So you see that this is here just a very bare bones HTML structure without any JavaScript in it at this point. Okay. And so let's now actually add some. Now, there are two ways in which we can add JavaScript to a website. And the first way is with inline scripts, And the second one is to add an external JavaScript file in which we can then add all of our JavaScript code. And let's start with the inline script. Okay, so all we have to do is to write script. Give it some space. And then in here, we can write our very first line of JavaScript. And what we're going to do now is to simply print to the JavaScript developer console some text. Okay, and so all we have to do is to write console.log and then some text. And we will write hello world. And this is kind of a standard text that we print out whenever we are learning a new language or like starting a new app or something like that. Okay, so hello world, you will see this here all the time when you search for tutorials on the web or something. Okay, and then to finish the line, we always have to add a semicolon like this. And so that is our very first line of JavaScript code here. So nothing really fancy, all it does is to log to the developer console this hello world text. Okay, then we give it a save and open it up in the browser. I have installed a brackets plugin to automatically save the file whenever I leave the app, and that's called autosave. And so I don't always have to save the file manually. Okay, so I'm gonna leave now here and then open up this folder, double click the file, and then it's going to open it right in the browser. So on the left side in our code editor, we write our code, of course, and then in the browser on the right side, we will have our results. And to actually see these results, we have to open up our JavaScript developer console. And you can do that by hitting Command Option J or Control Option J on your keyboard as a shortcut like this. Or you can also right click, hit Inspect, and then come to the console like this. And here you see that we already have our hello world printed to the developer console. And you see on this side here that it comes from index.html on line 13. So exactly this line that we have here. So great, it works. So again, nothing really fancy here. All we do is to log some text to the console. And that's what we're going to do here throughout the section. So we're going to log some text all the time to the console because we're not really doing anything here in the browser itself. So no real website, because that's something that we're going to take care of later. For now, we are just really learning the JavaScript language. And so logging some values here to the developer console is perfect for that kind of application. Okay, so this is how we do inline scripts here. Now let's learn how to add an external script to our site. Okay, so first off, of course, we create a new file, and I'm calling it script.js. Okay, and now let's actually add the same code here. So console.log, and then hello world again. And now I'm using 3 of these exclamation marks here, just so that it's a different kind of text here than before. Okay, then back in our index.html file, we can now, of course, delete this code here. We leave the script because we still need it, but now what we do is to define the source attribute. So we write source and then script.js. Okay, and so now our script file and our HTML file are linked through this. Now, if the script was like in another folder, like for example called JavaScript or JS, then we would have to write like js/script.js, but that is not the case here, and so let's get rid of that. And so that's already all we have to do to add an external script to our website like this. So let's come back here, reload, and now we have hello world again, but with our 3 exclamation points. And then you also see that it comes from script.js on line 1 now. And so that's exactly this text that we have here. Okay, and from now on, we will use this script.js file here because it's always best to have the code in an external file. So the advantage of the inline script that we had before is that we don't have to load an additional file, but it's still better to have everything in an external file because it allows us to nicely keep the HTML and the JavaScript separated in different files. Okay, and so that's what we're going to do throughout the rest of the course. Okay, and that's already it for this lecture. So you learned the difference between inline and external scripts, and you wrote your very first line of JavaScript where we logged this text here to the console. And with that being said, let's now move on together to the next lecture where you will learn what JavaScript actually is. So see you there in a second. So you already coded a line or two of JavaScript, but what exactly is JavaScript actually? Well, that's what we're going to look at in this video. And so in this lecture, we will set the stage for the rest of the course, and so it's really important that you follow this one until the end, alright? So, per definition, JavaScript is a lightweight, cross-platform, object-oriented computer programming language. Now that sounds a bit too much, right? But don't worry, it's simpler than what it sounds like. So lightweight just means that the language doesn't eat up much memory of the computer and that it has a relatively simple syntax and features. Cross-platform means that the language can be used on multiple platforms and systems, not just for web development. And finally, object-oriented means that it's a language that's based on objects. And we're going to explore all of that throughout the course. Now, as you already know, together with HTML and CSS, JavaScript is one of the 3 core technologies of web development. And more on that in a second. So for web development, JavaScript has traditionally only been used in the browser environment, which means that it was only a client-side language. However, more lately, thanks to a new technology called Node.js, developers are now able to actually use JavaScript on the server side as well. But that is a whole big topic for itself, and we will not cover that in this course. So as I mentioned in the beginning, this course covers the JavaScript language itself and how to use it in the browser, which is the more traditional way, okay? So in summary, JavaScript is what made modern web development possible. It allows us to not only add dynamic effects and interactivity to more simple websites, but it also allows us to develop complex modern web applications that we can interact with and that almost feel like the apps that we can use on our computers and phones every single day. Now, something else that I think is important to mention here is that today there are lots of JavaScript libraries and frameworks out there that implement different architectures and help developers build complex apps more easily and faster than ever. So I'm talking about stuff like React or Angular or even jQuery, which are all extremely popular, and I'm sure that you have heard of them already, right? Now the thing is, they are all 100% based on JavaScript, and so before using them, developers actually need to be really good at JavaScript. They need to be really able to understand the language itself. And that's exactly where this course wants to help you. So I mentioned that together with HTML and CSS, JavaScript is one of the core technologies of the web. And so let's go a bit deeper into that and talk about the role of JavaScript in web development. So HTML, CSS, and JavaScript all work together to create beautiful, interactive, and dynamic websites or web applications. Now, the HTML is responsible for the content of the page. So the text, the images, the buttons, and all the content that you see on a web page is always written in HTML. Then the CSS, of course, is responsible for the presentation of that content. So basically for styling and for laying out the elements on the web page. And then finally, JavaScript is the real programming language that allows developers to add dynamics into the picture, like interactive effects, manipulation of the content or of the CSS, and much, much more. So again, HTML is responsible for the content, CSS for the presentation, and JavaScript for adding real programming capabilities to websites. Now, another way to easily visualize the role of each technology is to put them in terms of nouns, adjectives, and verbs. So in this, like thought experiments, HTML does the nouns, like saying that the P element is a paragraph. So paragraph here is the noun. The CSS then is the adjective, because it describes the noun, like saying the paragraph text is red. And so there is the adjective. And then finally, JavaScript is the verb, like saying hide the paragraph. And so we are doing something here, and so we have a verb. Okay, does that make sense? And so that is the role of JavaScript in web development. And now just before we finish, I want to quickly mention that there are different versions of the JavaScript language. But I'm not going to go into that right now, and instead I'll leave that for the end of this section, okay? For now, I just want you to start coding as fast as possible. And so we're going to use a version called ES5 over the next couple of lectures. But again, at the end of this section, there's a whole very important video about this. In this video, you will learn about the fundamental concept of variables. So variables are a fundamental concept of every programming language in the world. But what actually is a variable? Well, we can say that a variable is like a container in which we can store a value in order to use it over and over again in our code, instead of having to write the value each time that we want to use it. Okay? So let's actually get rid of this code here. And so let me show you how to declare a variable for the very first time. So we have to use the var keyword and then the name of the variable. And I'm going to call this one first name, then equal, and then the value that we want to assign to the variable. In this case, what I want to assign is a text, a string called John. Okay, and then again our semicolon at the end. And so with this, we just declared our very first variable. So the variable name here is first name, and the value that we assign to that variable is John. So you can basically think of this variable, this first name variable here, as a piece of memory in your computer in which this John string here is stored. So I used these quotes here to declare this text here, so this string. Okay, I could also have used the double quotes like this, but I think it's a bit more modern to simply use these single quotes. All right, so when we declare some text, we usually just use the single quotes just like this here. All right, so throughout this section here, I will be using variables about persons for all the examples. So stuff like names or jobs or age or something like that. So something defined persons. So let's now do again a console.log. And what we're going to log now is simply the first name variable. All right. And so what do you think will happen when we reload our page now? So let's take a look at that. And indeed, you see John now logged to our console. And that's because we assigned John to this variable. And then JavaScript can retrieve the value of this variable here, which we declared as John. And so first name here is effectively the same as John. Okay, does that make sense? Let's now declare another one. And again, we have to use var. And now let's say last name equal. Then again, I use these quotes. And then let's say that it's Smith. So John Smith. So that's the last name. And let's declare another one called age. And so let's say that John is 28 years old. And so you see that now it's no longer a string like we had here, but it's now a number. And so that means that it's a different data type. Okay, so here we have text, but here we have numbers. Okay, and so now this is a good time to actually talk about different data types in JavaScript. So in JavaScript, there are 5 different data types: number, string, boolean, undefined, and null. And so far, we have already seen the number and the string, right? Now, primitive data type just means that it's not for objects, unlike most things in JavaScript. So they are just simple, primitive, non-object data types. So first off, we have numbers again, and JavaScript numbers are always floating point numbers, which simply means that they always have decimals, even if we sometimes don't see or even don't define them. So for example, 5 is like having 5.0, all right? And in other programming languages, many times it doesn't work like this, and you have different data types for integers and decimals, but not in JavaScript. So here all numbers are simply float numbers, even if they look like integers. Next up, we have strings, which are simply a sequence of characters, and so they are just used for text, like we did in the example before with the last name and the first name. Next up, the Boolean data type is a logical data type that can only take one of the logical values, true or false. So to make it simple, a Boolean is always either true or false. Okay, and we will see why this is very important over the next lectures. Alright, and the next one is a bit more difficult to understand. So basically, undefined is the data type that is automatically assigned to a variable that doesn't have a value yet. Sounds a bit more complicated than it actually is, and don't worry, I'm going to show it to you a bit later, of course. But what matters here for now is that basically undefined means non-existent. Alright? And finally, there is another data type, which is quite similar to undefined, and that is null. So null also means non-existent, but it's slightly more specific. And again, we will take more about these two later on. Now, before we move on, there's something very important to note here, which is that JavaScript has a feature called dynamic typing. And this means that we do not have to manually define the data type of a variable, unlike in many other programming languages. So basically, JavaScript automatically figures out if a variable is a string or a number, or if it's undefined or a Boolean, and then assigns that data type to the variable without us having to do anything. Okay? And if we then later assign another value to the same variable, but with another data type, then JavaScript will automatically change the data type of the variable as well. So this can of course be very useful and save us some coding time, but it can also be the source of some difficult to find bugs, which means errors in our code. Okay, so we always have to be careful with what we do with our variables. All right, and that's it. So let's now actually see these things in action again and move back to our code. So to show you the Boolean data type, let's create a variable here called full age. So var full age, and then say true. And remember that Booleans can only be true or false, and so in here we can simply say true or false. Okay, so I could of course also have written false, but in this case, well, John is of course of full age with his 28 age. And so let's now take a look at the console when we log this variable here. So full age, the semicolon, and then reload it. And now you see here that it's true. Okay, so it also appears in a slightly different color here. This one is blue, and the John string here is black. All right. So here it also looks a bit different. So it's of course not in quotes. We simply write out true like this because it's a reserved JavaScript keyword. Okay, now before we move on in this lecture, I want to quickly talk about these variable names here. Okay, so it's a best practice in always giving our variables meaningful names. Instead of simply writing something like X or ABC or something like that, we should never do that. We should always say in our variables what we actually want. Okay, or what this variable actually means. So in this case here we have John, and that's a first name, and so we call this variable first name and not just some random sequence of characters. Okay, and the same of course for last name, age, and full age. And so again, that's a best practice. Of course, it would work the same if we say A, for example, and then A here. If we now log it to the console, then of course John is still here. But again, we want our variable names here to really have some meaning. Then this way of writing the variable name with this first word here and then the name, where I separated them with a capital letter here, that's the so-called camel case notation. Okay, so we could have done it like this. So first name all together, but then it would be kind of difficult to find where the second word starts. We could also have done it like with an underscore, but in JavaScript, it's kind of a convention to use the camel case notation like this. Okay, so we start with a small letter in the beginning, and then when we have a second word, then that one starts with a capital letter. In the case of age here, for example, that's not the case because we only have one word. But then here again in full age, we have the second word here with this capital A. All right. So that's not about the JavaScript functionality itself. That's more of a programming convention and a best practice. Okay, moving on. Let's define yet another one. And this one I'm going to call job. Now the difference here is that I'm not going to assign anything to this variable. Okay, so I can declare a variable but not assign a value to it. And so let's see what happens when we now take a look at this variable. And can you guess what's going to happen here? I hope you can. And indeed, what we see here is now undefined coming from script.js at line 11. So this line here prints undefined to the console. And remember that when I showed you that slide, I mentioned that undefined means not existent. And so that's the case. So we declared the variable, but we didn't assign any value to it. And so therefore job is simply undefined. And so that's what we see in the console. We can then later go ahead and assign something to it. So let's say job is teacher. And if we do the console log then again, and let's just copy it here, well, then we should see the teacher. And here we go. So from line 14 comes the teacher after we have declared it here in this line above. Okay, so we have strings here, we have numbers, we have a Boolean, and we have also the undefined right here. And so these four are the most important data types that I wanted to show you. Now just to finish off this lecture very quickly, I want to show you some rules that we have to keep in mind when we name our variables. So I already talked about the best practices when naming them. So with this camel case notation that I explained before, but that was not really a rule, that was more of a best practice. But actually there are also some rules that we have to keep in mind. But don't worry, they're actually very simple. All you have to know is that variables cannot start with numbers or symbols except for the $sign or an underscore. Okay, so let's try to break some of these rules to see what happens. So var, and now I'm going to start a variable with a 3, so with a number. So let's try to say 3 years equals 3 and then reload the console. And now you see that we get an error here in line 16. And so this is here not valid. And again, because we cannot start a variable name with a number. All right. So I'm showing you this that in case you start naming your own variables, you don't run into these errors and then cannot figure out what this here means. So always take care and use these rules that I'm showing you here. Now, if we wanted to fix this here, we would either have to start with a number or with a $sign or an underscore. Okay, so these are the only symbols that can appear in a variable name here in JavaScript. So for example, with the underscore, it would work just fine. With the $sign as well. But as soon as I start putting something else, like this, well, then again, we get the error here, okay? And the same actually happens if I use a symbol in the middle of a variable name. So something like John/Mark, for example, John and Mark, and you will see that this here is not going to work again. Okay, so we have an error here at line 17 now, of course, but I want the error now on line 18, so let's take a look at that. And of course, it says unexpected token, which is this one. So in this case, we would of course use the camel case notation here to make it a lot better. And so now we don't have any error here anymore. So that was the first rule, that again, all variable names must start with either an underscore, a $sign, or a letter here. And then the second and last rule is that we cannot use reserved JavaScript keywords as variable names. So something like function, for example, is not going to work. So function equals 23, for example, and this will not really work. So you see unexpected token function. We can also not use something like delete, which is also a reserved keyword. And you will meet many of these keywords here throughout the course, of course. But right now, just know that any of these keywords that we're going to use later, something like if, for example, you will not be able to use these as variable names. So variable names really need to be our own made up words and not the words that JavaScript already uses in its language. And all right, that's actually all there is to know about the fundamentals of variables and data types. So that's already a huge step forward and a very important concept in any programming language of the world. In the next video, we're going to dive a bit deeper into variables and do some more stuff with them. So stay tuned for that next video. Welcome back. In this video, you're going to learn how to mutate variables and also how and why JavaScript does type coercion. But before we talk about any of that, I want to show you something else that we also have in any programming language in the world, and that is comments. So with comments, we can really comment like pieces of code and describe what they do. Okay, so let's try it out. And in JavaScript, there are two types of comments. There are single line comments, and we work them just like this, and then also multi-line comments. And I'm going to show you in a second how they work. But with single lines, we simply write // like this, and then we can do any text that we want after that. So in here, I'm simply going to write that these are the variable naming rules, okay? Because that's actually what I did here in these lines of code. So I showed you how we have to name our variables. And so now with this comment here, I can very simply describe that this is what we did here. Okay, we can also do a multi-line comment, and that is / asterisk, and then asterisk, and / again. And then on multiple lines. And everything that we put here in between will be a comment. So one line of comments, 2 lines, and so on and so forth. Okay, and here I'm going to use this multi-line comment to say that this lecture here was about variables and data types. So variables and data types, and this is also a common like pattern where you then add some asterisk here, just like this, basically just to separate these lectures. Okay, so variables and data types, that was the last lecture, and now in this lecture we will have variable mutation and type coercion. All right. Now, just in order to get rid of this code here so that it doesn't get in my way, I can also comment out this entire piece of code, just like I did before. So that's another common use case of comments, is where you basically comment out some code that you don't want to get in your way for some time. Okay, and so now I commented it, and now it will no longer be executed. So I can reload this now, and then we don't have anything logged to our console because all of this here is gray, and so it's really commented out. Okay. Anyway, let's continue with our person's example here and learn all about variable mutation and type coercion. Okay, so I'm going to reuse some of these variables. So first name is still John, and has also defined the age as being 28 again. So we have here two different data types, string and number. But let's see what happens if we want to print them together to the console. Okay, so let's give it some space here. I prefer when this text here is a bit more at the top. So console.log, and so let's basically do a string which contains John space 28. Okay, so we can say first name, then we can use the plus symbol, and I'm going to explain you later that this is an operator. So for now, let's just simply use this here to join these strings. Then we can do a space, and then another plus to add the age. Okay, so we are hoping that this here will then become John space 28 to the console. Okay, so let's check that out. And indeed, we have John 28. So how did this work? Because remember that age here is actually a number and not really a string, but still it logged it here as a string in this entire John 28 string. And so this works thanks to something called type coercion. Okay, so what this means is that JavaScript automatically converts types from one another as it's needed. And in this specific case, it converted this number here to a string in order to be able to join these three strings. So John is a string, then this space here is also a string, and then age, the number, will automatically be converted by JavaScript also into a string, so that it can then join all of these strings into one bigger string. And so automatically JavaScript does this work for us here by a process called type coercion. And other programming languages are not like this. We would have to convert our variables, but JavaScript is easier. It takes all that work away from us and does it automatically. And joining strings like this here is just one of many examples of type coercion that we will encounter throughout the course. So type coercion here happens all the time in JavaScript. All right, let's now try out another example here with joining strings. And so let's create some more variables. So job, and now I'm going to show you something different, which is basically to declare many variables on the same line and then define them later on. So job, to say John's job, and then we can also define a variable called isMarried. So basically like a marriage status saying true or false whether he is married or not. And now we can say job is teacher, and then that isMarried is false. Okay, so we declared both of these variables here, and they are then undefined, remember? So that's what we had here. So I declared the variable here, job in this case, and it was then undefined, remember? And only later in this line here, I then assigned a value to that variable. And so that's the exact same thing that we do here. So here we declare multiple variables on the same line, and then I assign the values to them here in these different lines. Okay, and so that's also actually like a common practice. In case that we want to declare many variables, it's a bit cleaner to do it like this, all in one line, and then simply assign them the values a bit later. Now what happens if we want to log to the console a variable that has a boolean here included? So let's try it out with console.log, first name, and then let's say, so John is a, and then the age here, year old, and then finally the job. And if we then want to include the boolean that we defined before, well then we can also like, let's say, is he married? So we kind of ask a question here, and then let's see what happens when we try to join the isMarried variable here into the string. Okay, so that looks a bit confusing here, but what should happen here is John is a 28-year-old teacher. Is he married? False. So let's take a look at that, and we get this error here, and that's just because I was missing this plus sign here. Let's try it again. And so John is a 28-year old teacher, is he married? False. And so you see that even the Boolean here gets converted to a string. So JavaScript also does type coercion with Booleans. And if we now actually take away this variable here, and so I'm commenting it out here, well, let's see, then it should say undefined. Okay, so even the undefined is coerced into a string, so basically converted into a string. Okay, let's take a look again, and so now it says false. All right, so this is type coercion, and now again I can write a comment here saying what we did in this particular section here. Okay, and now let's actually look at the variable mutation. So variable mutation basically means to change the value of a variable. And so that's something that we didn't do up until this point, but of course that's something that we can do with JavaScript variables. And so let's now redefine the age. So we can say age equals 28, for example. And so this time we don't use the var keyword. So this part is not necessary because the variable was already defined before. It's already declared here in this place with the var keyword. And so when we want to change it, we no longer need the var keyword. So all we say is age and then the new value. And in this case here, it is 28 as a string this time. And so as I explained to you in the last lecture, JavaScript automatically figures out the data type and can change it on the fly. So before it was a number and now it is new and it's a string. So that is the magic of the JavaScript dynamic typing. Okay, we can also of course change something else. Let's change the job here. So job, and let's say driver. All right, and so let's now log it again to the console. Or instead of logging, I want to show you something else. So we've been logging these values to the console all the time, but now I want to use alert. So let me show you what alert is going to do. And it's this beautiful window here. So we get a pop-up window basically. So John is a 28-year-old driver. Is he married? False. Okay, and so this time it's not in the console, but instead it is like this small pop-up or alert window. And you see that basically the page here keeps loading until we actually hit OK here and make this pop-up disappear. So the page is loading. It's not really, it cannot really finish its work until we hit OK on this. Okay, so we did some variable mutation here and type coercion we also observed. I showed you the alert, which is an alternative to console.log. Let me just show you something else here, which is that we can actually in an easy way get data from the user with a similar method that alert. So we can use prompt and then basically ask a question here. So let's say, what is his last name? Okay, so we say prompt, what is his last name? And we will then be able to input a value. And that value we can then store into a variable. So var last name. So that's what we're asking for here. And then we can log it to the console just to make sure that everything works. So last name, and we can also add the first name here. Okay, so that's the pop-up from before, so this alert here. And now here comes the prompt. Okay, so what is his last name? And let's say Smith. And now this will be stored into the last name variable. And then we can log this variable to the console. So first name plus the last name will of course give John Smith. So Smith is what we just defined. If we now say like Miller, then it will log John Miller. Okay, so that's our input coming from that window. Great, you're progressing at a great level here and already learned a lot of JavaScript. Of course, there's tons more to come, and so let's quickly move on to the next lecture where we're going to talk about some basic operators. So like doing math operators and compare different values with one another. So stay tuned and see you in a second. Let's now learn about a couple of basic JavaScript operators. So here I already created like the title for this lecture and also commented out the code here of the last lecture. Okay, so we could actually do this here in different files, like one file for each lecture, but I prefer to just keep it everything simple here, all in one file. Now for operators, They can be, for example, the simple math operators that we already know, like plus and minus and times. And then beside that, in JavaScript, we have a couple of other operators that I'm also going to show you. So in simple terms, operators are like functions that are written in a special way in JavaScript. And in case you're wondering what functions are, don't worry. Again, we will talk about this a bit later. But for now, let's actually take a look at some math operators and how we can use them in JavaScript. So let's calculate in what year John was born. And that's very simple. So let's call it year John. And so we have 2018, which is the current year, minus John's age, right? And remember, we used to declare it as 28. And so let's use the same here. And so now we can then log it to the console. So let's take a look at that. And indeed, 1990. Okay, so this year the minus is a math operator in JavaScript. And let's not do the same for, let's say, for someone else, like John's friend. Let's say he's called Mark. And so 2018 minus 33. So Mark is 33 years old. And now you see that we are starting to repeat some of the values. So for example, 2018 here, we are using it multiple times. And so let's declare it as a separate variable. So that is what variables are for. Okay, so we can say var year is 2018. And so now instead of having to reuse this 2018 here, we can then write year in these two places. Okay, so let's take a look at that. And of course, it still displays the exact same number. But if we wanted to change the year now, let's say to 2020, well, then we wouldn't have to change it here in these two places like we had before. So before, if we wanted to change the year, we would have to change it both here and here. And that's something that we always want to avoid in programming. And so we define this year in one place, and then it gets used in these two places here. Okay, and actually let's also declare all of these variables here in the same line like I showed you before. So year, then year John, and year Mark. Okay, and then remove these vars from here. So this just looks a bit better. So that is just the minus operator here. But of course, we can do all kinds of math here. So for example, we can multiplications. So let's say we wanted to add 2 years here. And so now is not defined. So this is of course not now, but it's year. Well, actually this should be called now because now is the current year. So 2018. So what we want here is this to be called now, and also here and here. All right, and so let's take a look at what happens then. And indeed, it logs 2020 to the console, which is 2018 plus 2, right? Of course, we can also multiply. So let's say now times 2, and we can, of course, also divide. So let's divide by 10 here. All right, logging it all to the console. Well, then, of course, we see that this is 2018 times 2, and this is 2018 here divided by 10. And so we end up with this like decimal number here, okay? So these are the math operators that we used here. So let's add a comment here saying that. And now I'm going to show you some logical operators. So let's write that down here as well. And so let's say that we want to compare the age of Mark and John and figure out if, for example, John is older than Mark. And so for that, we can use a logical operator. So first of all, let's actually define these ages here as different variables. So age John is 28, and then age Mark is 33. And so of course here we use age John and then down here age Mark. So let's create a new variable here called var John older. And then we will say age John greater than age Mark. Okay, and then of course we need to log it to the console here to see our result. And so let's take a look at what happens now. And we see our result is this boolean and it's false, okay? And so what this means is that age John, which is 28 here, is of course less than age Mark, which is 33. And so basically here we ask the question, is age John greater than age Mark? and the result of that is false. Okay, and so our John older variable here turns out to be false. Now if it was the other way around, if we asked age John less than age Mark, well, then it should be the other way around. And so yeah, indeed it is now true. Again, because age Mark is 33, which is more than 28. And so we have a way now of basically creating a Boolean variable using one of the logical operators that I just showed you. And there are many more that we're going to explore a bit later in the course, and actually in this section in a couple of videos. So math operators here are pretty straightforward. Then these logical operators, which are also very important, as you're going to see later throughout the course. And then before we leave, I also want to show you the type of operator. Okay, and this operator is a bit different than the other ones. So the ones that we used up until this point always required like two things to compare or to add or to multiply. So now times 2, or now divided by 10, or age John less than age Mark. So we always had two operands. But with the type of operator, we only have one. So let me show it to you. And so let's log to the console the result of using the type of operator on, let's say, the John older variable. Okay, and so basically what this will do is to tell us the type of this variable. And so indeed we get Boolean. And that's because obviously this is a Boolean variable. So we saw that here as it returned this true. And as you learned in one of the last lectures, a true or false value is always a Boolean, right? Remember that? So let's try it out with some other stuff here. So type of, and let's now say age John, and this should be a number. And indeed, it is. Let's actually copy this now. And let's try it out with a string. And we don't have any here. So let's just write it ourselves. Mark is older than John, for example. And then also, let's try something else. So let's just declare a random variable here and not define it. And then let's log to the console the type of this. And so what do you expect that the type of X will be? So let's test it. And I hope you know that it will be undefined. Okay, so that makes sense. Because indeed, we did not define any value for the X variable. And the one before here, of course, is string. So this may not seem like a big deal to you here, this operator, but actually you will see that we will use this here in the future, and actually also later in this section. Okay, so this is the very basics of JavaScript operators. Now in the last lecture, we will keep working with operators, where I'm going to show you some more, let's say, advanced stuff. So don't wait and come with me right to the next video. Hey there! In this lecture, we will continue talking about operators and operator precedence. So for this example, let's say that we want to calculate if John is of full age only based on the year in which he was born. So let's first declare a couple of variables. So now is 2018. The year John was born was 1989. And then we also define the full age variable. And that's the age at which you officially become of full age. So in most of Europe, that's 18, maybe in the US, it's 21, I'm not sure, but let's use 18 here for this example, okay? And so what we can do is to calculate the age and then compare it with 18 here. And we're missing the equal sign, of course. And so what I want to do is to do all of that calculation all in one line, okay? So var is full age and then equal now minus year John, and that will calculate the age. And then we want to test if it's greater or equal to the full age. Okay, so does that make sense? So let's take a look at this and try to figure out why this works. So you see that we have actually two operators. We have the minus and then this logical greater or equal operator all in one line. So all in here. Now, how does JavaScript know which operator actually to execute first? Because imagine that first this here would be executed. So we would ask if year John is greater or equal of full age, which would return a true or false value. And then we would do now minus this true or false value. And so this would be nothing significant. So this would not be what we want. Instead, what we want is for this year to be executed first. So now minus the year of John, and then we want to compare that age with the full age. So this here works, and let's actually test that. And I'm going to show you why in a second. Okay, so this actually returns true. And of course, John is of full age. So in 2018, born in 1989, he is 29. And so of course, he is of full age. Now, in order to figure out why this works here, we have to think about operator precedence, which means which operator is executed first. And so if you come here to my resources page at codingheroes.io/resources, down here in the JavaScript section, you will find this operator precedence. Okay, so let's open up that link. And then down here, we have the operator precedence table. And so what we see here is that the operators that are here on the top of the list will be executed before the others. So you see that the one with the highest precedence is using this grouping here with the parentheses. And I'm going to show you that in a second. But what we're interested in here is our plus, or actually our minus operator, which is this one, and our logical operator greater or equal. So this one here. And so what we can see from this table is that the minus operator has a precedence of 16. Okay, so that's what this value here is the precedence value, which is greater than the one from the greater or equal operator, which is only 11. And so what that means is that this minus here will be executed first. And so all of this is executed first, and then we end up with the result here. So in this case, it will be 29. And then only after that, 29 will be compared with the full age with this operator, which has a lower precedence with only 11. Okay? And so after that, we end up with the result, which in this case here will be false. So let's actually write that here. Or actually, it is true. And so right now we have var is full age equals true. And what I want to show you next is that the equal operator itself, and where is it? Ah, here it is. So the assignment operator, as it's called, is also an operator itself. And I mentioned that to you in one of the last lectures, and now it makes sense. Okay, so you see that this equal operator is the one with the lowest, or almost one of the lowest, precedence. And that makes total sense, because of course we want the assignment to happen as the last step. So after all the other operators have done its work, in this case or minus and or equal or greater than operator, they are all have done their work now, and we end up with the true result. And so as a final step, it is then assigned to the isFullAge variable. All right, does that make sense? So actually we not only have two operators, but we have three. The first one that gets executed is this one, then this one, and finally the assignment operator. All right, and whenever we need to know if something works, the order in which our operators work, you can always just consult this table here, which is why I put it here right on my resources page under the JavaScript section. All right, so let's now look at another example where we want to calculate the average age of John and his friend. So let's say age John, because we haven't really calculated it. We only calculated it here. So let's actually grab this here. So now minus the year John, and then the age of Mark. And let's just say it's 35 without any calculations here. And so the average will be to basically calculate the sum and then divide it by 2. So age John plus age Mark divided by 2. But this is not really correct, right? And you know that from your math classes that you had in school probably. And so you know that this dividing operator here will have precedence over the plus, okay? And so let's confirm that in JavaScript it also works like that. And you can see that right here. So the division here has a higher precedence of 14 than the addition of 13. And actually when we talked about this example here, I mistakenly used this operator here, which is the unary plus, but I meant this one here, so this addition operator. But of course it still has a higher precedence than the greater. Okay, so it doesn't really matter using this here or the unary plus operator. Okay, it's a different operator, but in terms of precedence, the addition is still higher than this logical operator. Okay, anyway, what we need to do here is to group this here together with parentheses, just like, again, you learned in your math class probably. And so that makes sense because we see up here that with the highest precedence, we have the grouping. Okay, and so that's using parentheses. And so if we do this, well, then this operation here has the highest precedence. So first we add up the age of John and Mark, and only then we can divide it by 2 in order to create the average age. So let's just take a look at it in the console, just to make sure that everything's working correctly. And so indeed, it is 32. And that's because, and let's quickly do it here in the console, 35 plus 29 is 64, and 64 divided by 2 is of course 32. So this calculation here is correct. Let's just add some comments here. So this is with multiple operators. Then here we have grouping. And now let's do some more examples with grouping and multiple assignments. So let's say that we have a value that we want to assign to multiple variables at the same time. And that's totally possible in JavaScript. And so let's create 2 variables, x and y. And so right now I'm not really creating variables with a meaningful name here, but that's no problem. This is just for doing some mathematical operations, okay? And so let's just start by saying x equals, and just some math operations here, let's say 3 plus 5, and then times 4 minus 6. Okay, so just something like this. And so we already know which will have precedence here, right? So the grouping has precedence, and this will then turn out to be 8. And so let's actually write it down here. So after the first step, we have 8 times 4 minus 6. Then the next step will be this multiplication here, right? So 8 times 4 is 32 minus 6. And finally, this will then turn out to be 26, okay? So x will be 26, and let's log that to the console, just to make sure. And indeed, here it is. So 26 is the result of this calculation. And so, as before, it did all of these operations, and only then it did the assignment. Now, if we wanted to assign this to x and y at the same time, we could very simply do x equals y, and then equals this entire calculations here. Now, the question here is why this actually works. Imagine that we're reading this line here, and we see x is equal to y. And so at this point, y is still undefined, right? Because we didn't define any value for it before this line. And so it would be kind of logical that x would be undefined at this point, but it is not. Let's take a look at that actually. And this is something that we didn't do before, which is to log 2 things at the same time. So we can say console log and then x and then a comma and then another variable. And so we see 26 and 26. So 2 results at the same time with the console.log. And so what we see here is that 26 is not undefined, which would be logical. So again, because y is undefined at this point, and if we say x equal to something that is undefined, well then x should also be undefined, but it's not. And so let's take a look at why that happens, and I can show it to you here in the table again. So we have the precedence here that we already talked before, but we also have the associativity. And what this simply means is the direction in which the operation is executed. So if we come down here to, for example, the multiplication or the addition, we have left to right. Okay, and so all it means is that, for example, if we had, let's add it as a comment, if we had 2 plus 4 plus 5, then it would do it from the left side to the right side. So first the 2 plus 4, which is 6, and then 6 plus 5 to 11. But there are some operators that work the other way around, so which are right from left. And the assignment operator is one of them. So here we have assignment, and assignment works from right to left. Okay, so that's the other way around. And so that is why this piece of code here actually works, because we end up with the result here of 26, and then the assignment works from right to left. So it doesn't start by doing x equal y, but instead it starts by saying y equal 26, and only then it does x equals 26. Okay, does that make sense? So again, the assignment operator works not from the left to the right, but from the right to the left. And so here we end up with a result of 26, and then that is assigned to y, and then that again in turn is assigned to x. And so therefore we end up with 26 in both these variables. Okay, so that is the associativity. That's the second part of the table that I wanted to show you. So we don't just have to keep precedence in mind, but also the associativity. All right. And now just to finish this lecture, I just want to show you some more operators. So let's say that we wanted to double x. So something like x equals x times 2, right? So that would be the double of x. But you see that we're actually repeating the x here. Okay, and so in JavaScript, there's a way of making this a bit more simple, which is simply saying x multiply equal 2. Okay, and so this is the exact same thing. So what this means is that basically it will do x times 2 without us to having to write out that x times here like we did here. Okay, so let's take a look at the result. And so 52 is indeed 26 times 2, which was x before. And the same thing would work for plus, minus, or multiply. So we can say x plus equal 10. And so what do you think this will turn out to be? And I hope that you guessed 62, right? So that is 52, which is the result from before, plus 10. So it's the exact same thing as writing x equals x plus 10. All right? So that makes our lives a bit easier. And these operators, you have them down here in the assignment section, because they are actually assignment operators, just like the normal assignment operator. Okay, and now just the last one that I want to show you is the increment. So what we can do instead of writing x equals x plus 1 would be to write it like this. So we could do x plus equals 1, but there's an even simpler way if we only want to add 1. And that is to simply write x plus plus. And so this operator simply adds 1 unit to the variable that we're using this operator on, okay? So this is all the same thing here, but of course this one is the easiest to write and the most handy one. So just to prove you that it actually works, let's log this one to the console as well. And so it's of course 63. And the same way it works with minus minus. And so right now it should be 61. And yeah, indeed it is. So that was a lot to take in up until this point. You learned all about variables, data types, and also operators. So I hope that it's all making sense to you, that you're having some fun. And so next up, there's coming a coding challenge where you can put all of these new skills to practice in a fun and small challenge that I have for you in the next video. Welcome to your first coding challenge in this course. And so this is the challenge that I want you to take. So Mark and John are trying to compare their body mass indexes, which is calculated by dividing the mass by the squared height. Okay, so this formula here. And to calculate the square of a number, you simply have to multiply it by itself. And so the final formula becomes mass divided by height times height. Okay, and here note that the height must be in meters and the mass in kilograms. All right, now the first step that you have to complete is to store Mark's and John's mass and heights in different variables. Okay, so just like we've been doing all this time up until this point. Then next up, calculate both their BMIs, then create a Boolean variable containing information about whether Mark has a higher BMI than John, and so that again we did before. And then finally, you can print a string to the console saying something like, is Mark's BMI higher than John's? And then the Boolean that you created or that you calculated in step 3. Okay, so true or false. And so this is, again, very similar to something that we did before. And so this should be not a big problem to you, hopefully. Now, if you find some problem here, if you cannot really solve it, then it's absolutely no problem here, okay? So don't beat yourself up if you're not able to 100% complete this. So everyone has different learning speeds and learning styles, and so it's really okay if you're not able to do it 100% on your own here, okay? So if you need to look up something that we did before, that's not a big deal, but you should really try to remember the stuff that we did before and use that to solve this challenge, okay? Anyway, the solution to this is in the next video where I'm going to show you how I would calculate this. So good luck with this, and see you in the video after you complete this coding challenge. So here goes my solution to the coding challenge. We start by defining the variables. So var mass mark equals, let's say, 78, and you could use any numbers that you wanted here, so I didn't define what the masses and heights were. Just remember that they have to be in kilogram. Let's give us some more space here. So we have mass mark, then we have height mark. Let's say 169 meters. So not really tall. Okay, and we could declare all of these variables here in one line, but I'm not going to do that right now. I'm just going to declare them one after the other. So Mark and now John, 92 kilograms, and then the height. And so that's step number 1, I think. Now, next step, calculate both their BMIs. And so BMI Mark is Mark's mass divided by the square of his height. So height Mark times height Mark again. And then body mass index John. So mass John divided by height John times height John. So that was step number 2. And now we want to create a Boolean to determine if Mark has a higher BMI than John. So var Mark higher BMI. And so all we have to do is BMI Mark greater than BMI John. So that should be our Boolean variable, and now we can log it to the console. So is marks, and now we cannot just write a quotation mark to write marks, okay, because then that would be outside of the string. So this marks the beginning of the string and this the end of the string, but we still want to have the symbol here to say marks. And so what we have to do is to escape this quotation mark, and we do that by adding this backslash. Okay, so that is called escaping, and that's something really common in programming as well. So is Mark's BMI higher than John's? And now again we need to escape and then close that string. So we have our string, is Mark's BMI higher than John's? Actually we want to ask a question, and then we say plus, and now you know that is an operator. And so we basically add strings together and then mark higher BMI, which should whether be true or false. So let's load it. And so is Mark's BMI higher than John's? And it says true. And let's actually also log these two BMIs to the console, just so that we're sure if everything's working correct. So console.log. And remember that we can actually log two values to the console at the same time, simply by adding the comma here. Okay, so Mark and John. And so we see that the first one is 27, so Mark is 27 and John is 24. And so Mark's BMI higher than John's, and of course, yeah, it's true, because of course this here will return true. So it will give us the result of true, which will be assigned to Mark higher BMI. Okay, so that's the solution to the challenge. Of course, you could have done it differently as long as the solution is the same. So in programming, many times, there's not just one correct solution. There are many ways to solve the same problem, okay? And that's something very important that you should know and that you should keep in mind always when you're programming. So there's not one correct way to solve a problem. There are always many ways. And so if you solve this in a different way, which is still correct, then it's absolutely valid. And it's great that you found a different way of solving this from my way. And so, yeah, let's now move on to the next video. Welcome back to the next lecture. And this is a very important one, because in this one, we're going to start taking decisions using code. So JavaScript, as well as most other programming languages out there, has a couple of control structures, which are features that allow us to execute only certain parts of our code or to execute parts multiple times. And the first control structure that we will talk about is the if-else statement, which is a conditional which basically allows us to take decisions using code. Okay, so let me show you how that works. And first, let's bring back some of our variables. So let's say first name is again John. And now let's create a variable that we didn't use before, which is for the civil status. So civil status. And so this one basically says if you're married or single or divorced or something like that. And so let's just say that John is a single. Okay, so he's not married. Now what we want to do here is to log a string to the console whether he is married or not. Okay, and for that we can use an if-else statement to take decisions. So we write if, and then we open parentheses, and then in here we have to write a logical condition. So something that returns a Boolean true or false value. So that's something like we did before. So for example, this one here. So this will return a true or false value. And so it's a perfect logic condition. Okay, now in this case, we don't want a greater or a smaller comparison like the one that I showed you, but instead we want an equality operator. So basically what we want to do is to test if the civil status is married. So let me show you how to do that. So we can say civil status equals married. Okay, and so this condition here will return true if the civil status is married and false if it's not. Okay, so this here again is like a logical operator which returns true or false. There's also the version with just two equals, but let's talk about that one a bit later. Okay, so again, this here will test whether the civil status is married or not. And then we open curly braces, and then this here is the block, so the if block. And in here we can now write our instructions basically. So in this case, our console.log. And what we want to log to the console is first name is married. So if the civil status is married, then this text here will be logged to the console. And if not, well, then nothing happens. So let's reload it. And indeed, nothing happens. And that's because right now, this here turns out to be false, right? Because the civil status is actually single and not married. And so this is different. And so when we have false, well, then this piece of code is not executed. Let's change it here to married for a second, just to see if it's working just fine. And it is. So now it says John is married because the civil status is the exact same thing as married here. All right. Anyway, let's change it back to single because now I want to show you the else part of the if-else statement. So we can have only the if part, but we can also add an else statement. So we can say else, and then we have the else block here. And so what this does is that if this is not true here, so if it's false, well, then it will execute the else block, okay? So let's test that out. We'll hopefully marry soon, okay? And so that of course means that he is not married at this point. So let's test it, and let's keep in mind that here it says single. And so this part here will not be executed because this here is false. And that means that we're gonna jump right to the else block. And so this text here should be logged to the console. Check it out. And yeah, it works. So John will hopefully marry soon. Now let's say that we actually have a Boolean variable already. So we can have a variable called isMarried. And let's set it to false. And let's then test what happens in that case. So instead of this test here, we could put isMarried, and then we could put equals true. But that part is actually not really necessary, right? Because what we need here in this condition is a true or false value. But this isMarried variable is already a Boolean. So right now it is set to false, but we could also set it to true. So let's do that. And so again, what we want here is a true false value. But isMarried is already true, so it is already a Boolean. And so this part is not even necessary. Okay, does that make sense? So here we just need a true false value again. So no need to write the true. Let's test that. And now it says John is married here, coming from line 173. So this one here. Of course, this one here is still coming from this if-else statement from before, where we say that the civil status is single and not married. But this is just another example where I wanted to show you that it's actually enough to pass a true or false value here into this condition. Okay, so I hope that makes sense, that you now learned how we can make decisions using code. And of course we could do much more difficult and much more complex stuff into these blocks, the if block or the else block. All right, now just to finish this lecture, let's bring back the code from our coding challenge that we coded up before, and let's basically write something better to the console. Okay, so what we did here is to simply log this string here and then together with this true false value. So that's not really the best solution, right? To just print true false to the console. So now that you know the if else statement, we can do a lot better than this, right? So what we can do instead of all of this, let's comment it out actually, is to write if BMI Mark is greater than BMI John. Well, in this case, we want to print something to the console, and if not, then we want to log something else. Okay? So in this case, we have, of course, marks, and now the escape string. Then John's, and of course the escaping. All right, let's copy it. And so here it's the other way around. Higher than marks. Okay, so let's quickly recap what we did here. So we're testing if the BMI of Mark is greater than John's. Okay, and so this here, of course, as you already know, will return a true or false value, and that is exactly what we need in an if-else statement. And so in this case, it will then log to the console Mark's BMI is higher than John's. And if it's not, so if this here is false, well then of course John's BMI must be higher than Mark's. And so then that's exactly what we log to the console. All right, and now just to test it out, we say Mark's BMI is higher than John's. Just missing the S, but that doesn't really matter. And just to test the other scenario, let's quickly increase this mass here. And so now John's should be larger. And indeed, so now John's BMI is higher than Mark's. Okay, putting it back. And so now again, Mark's should be higher. And indeed, it is working. And so now you know how to take decisions with code. That's awesome. But this is really just the fundamentals of conditionals and decision taking with code. And so there's a lot more to learn. And so yeah, stay tuned for the next videos. Let's now take conditional to the next level and learn about Boolean logic. And in this small example, we want to log to the console, depending on John's age, if he is a boy, a teenager, a young man, or a man. Okay, and so let's start again by defining the first name as John and then the age. And let's start here with 16, for example. All right, so we use our if-else statement, and we can say that if John is younger than 13, well then he is a boy. All right, so console.log first name plus is a boy. All right, and then we can say else, and let's just copy this line of code here, is a man. Okay, so that covers the boy and the man, but how do we actually decide if he is a teenager or a young man? We need some more options here, right? And we can actually do that with JavaScript. So instead of just having the if and the else block, we can also have an else if block. Okay, so let me show that to you. So here we can have else and then a new if. So let's put it back here. And so here we can put some more text. And actually we need to add a new condition here. And so what do we want to have here? So let's first put in the result here actually, so that we know what we're actually talking about here. So let's say that he is a teenager. And so teenager basically means that he's between 13 and 20, right? So let's write that down here as a comment. Between 13 and 20. Well, how do we write a logical condition to express exactly this? So how do we say that the age should be between 13 and 20? Well, that's kind of difficult, right? So let's think about it a little bit more. So between 13 and 20, what this really means is that the age is greater or equal 13, right? And at the same time, it's also less than 20, right? So again, having an age between 13 and 20 should mean that the age is equal or greater than 13 and less than 20. So these two conditions here at the same time, okay? And so what we need is an operator for this. And so there actually in JavaScript is an AND operator. And in order to learn how that AND operator works, we need to talk about Boolean logic. So in a very broad sense, Boolean logic is a branch of computer science that deals with true and false values. And it's actually something quite important in coding, and so you should make sure to really understand this part. All right? Now, there are several logical operators that deal with true and false values, but the most important ones are the not, and or operators. So let's start by looking at the AND operator. And here we have a table called a truth table, which allows us to see the outcome of the operator. So the AND operator works like this. Suppose that we have two variables a and b. Only if variable a and variable b are both true, the expression a and b will become true, okay? And in all other cases, the result will be false. And that's why it's called the AND operator, because a and b must both be true in order for the result to be true as well. So if either a or b is false, well, then a and b will become false as well. And the same applies if there are more than two variables. Only if all the variables are true, then the AND expression will become true as well. All right, and now the second truth table is for the OR operator. And here things work a bit differently. So with the OR operator, it's enough for one of the variables to be true in order to make a or b come true. And again, that makes sense, right? So it's called the OR operator because only a or b needs to be true in order for the final expression to be true. The result will only be false if both variables are false. And we can see that here in the truth table, right? And once more, it works the same way with multiple variables. So it's enough for one variable to be true to make the final result be true as well if there are like 3, 4, 5, or even 10 Boolean variables. So that's how the AND and true operator works. And then finally, there's also the NOT operator. And this one is really simple. All it does is to invert the true or false value of a variable. So if variable a is true, then not a is false. And if a is false, well, then not a is true. So easy, right? Let's now look at a couple of examples. So we start by defining a variable called age. Then we have age greater or equal than 20, which is of course false because 16 is less than 20. Then we have age less than 30, which of course is true. And finally, we have the not operator. So we know that age less than 30 is true. And we know that the not operator inverts the value. So not age less than 30 is of course false. Makes sense, right? Okay, so the next expression, we already know that the first part, age greater or equal than 20, is false. And we also know that age less than 30 is true. So here we have false and true. So can you guess the result? That's right, it's false, because they're not both true. Okay? Now the next expression is similar, but we have the OR operator here. So it's now true or false. So what will the result be this time? All right, now it's true, because with the OR operator, it's enough for one of them to be true. So I hope that made sense, and so we can now go back and use what we just learned in code. Okay, and now that we know about the AND and OR operators, we actually have a way of writing out the expression that we need here. So what we want here is the age to be greater or equal to 13, and so the AND operator, as you saw before, we write like this. And so we want age greater or equal to 13, and at the same time, the age to be less than 20. Okay, and so that's all we need. That is our expression here, or basically our testing condition. So let's say that the age is 16, so as it is right now. So if we now load this, well, then we log to the console, John is a teenager. And so it's actually working. So right now age is 16, and so age is in fact greater than 13. So this part here is true. Then the age is also less than 20. So this is also true. And so true and true makes true, as we just learned. And so then this block here is executed. Now just quickly talking about the precedence of this operator here, well, it has to be lower than the precedence of these ones here, right? Because of course we first want this to be executed in order to end up with a true or false value, and then this one here. And only after that we want to combine these true false values using this operator here. And so of course the AND and OR operator, they must have a lower precedence than these comparison operators, right? So let's check if that's actually true. And indeed it is. So the logical AND and OR, they have a lower precedence of 6 and 5 than these comparison, like less and less than equal, greater, and oh yeah, all these comparison operators here. So they have a higher precedence, and that's why it works the way it works here. Okay? And now just the final step, because we want a boy, teenager, and we also want like a young man between 20 and 30. Okay? So let's create a new else if here. Here the condition, and open a new block. So a young man. And what do we want the age to be now? Well, we want it to be greater or equal than 20, and at the same time it should be less than 30. Okay, and if we didn't put this equal sign here, well, then the 20 wouldn't be covered anywhere, right? So let's take this out here and go to 20, so set the age to 20, and let's see what happens then. So now it says John is a man. Okay, and that's because this 20 here is not included neither in this condition nor in this one. So here it's just less than 20, and here it's greater than 20, but nowhere is the equal sign. And so that's why we have to include it right here. Okay, we could also have included it here, but well, someone who is 20 years old is not really a teenager anymore, and so we include this equal sign up here. And if we reload it now, well, then it's gonna say young man. Okay, and so that worked just fine. All right, and I think that is enough for this lecture. So you learned all about Boolean logic and the AND, OR, and NOT operators, and also that we can add these else-if blocks here to our if-else statements. Okay, so we can have multiple, let's say, if-else statements all in one construct like this. Okay, so make sure that you understand all of this. If necessary, you can maybe review parts of the lecture, and then let's just move on to the next video. In this video, we will look at some more ways of taking decisions with JavaScript. So you've learned about the if-else statement in order to take decisions, but there are more ways of doing this. And so the first thing that we're going to look at is the ternary operator, which is also called the conditional operator. And it is an operator that basically allows us to write like an if-else statement all in one line. Let's take a look at how that works. And again, I'm bringing back my first name variable here. And then we're also going to set the age to 16. And so now let's use the ternary operator in order to log to the console if John drinks a beer or if he drinks juice, depending on his age. Okay, so let's say age greater or equal to 18, which is the legal age at which you could start drinking, at least in Europe, maybe not in the US. Okay, so we start here with the condition. Then we use the question mark. And then we write basically what we want to happen if this condition is true. So this is like the if block in an if-else statement. So in this case, we want to log to the console, console.log. Drinks beer. Okay, so that is the first part. And now we also have to write the else block. Okay, and so for that, we use the colon. And then let's actually go ahead and copy this part here. Drinks juice. Okay, and that's actually it. So this is the ternary operator. And it's called ternary because it has 3 operands. So basically 3 parts that interact with the operator. So we have the condition first, Then we have the if block here, basically, and then the else block. So let's now test if that works. And indeed, it now says John drinks juice, and that's because he is younger than 18. If you set it to 22, let's say, then it will say John drinks beer. Okay, let's take a look at another example, because we can do even better and assign values to variable using the ternary operator in a very simple way. So let's say that we want to define a variable saying what John can drink. So let's say var drink, and now we can use the conditional operator right here. So age greater or equal than 18. Then the question mark, so basically this is to ask a question. So is John greater or equal than 18? And if he is, well, then we can say beer. And if he's not, then we can say juice. And that's it. So basically the result of this entire code here will be beer if the age is greater or equal than 18, and it will be juice if not. And this result will then be assigned to the drink variable. Okay? So again, this is an operator here again, and so an operator always has a result, just like we saw before with any of the other operators. Okay? And so this operator, this ternary operator, is executed, of course, before the assignment operator. Remember, this one is also an operator. And so first we execute this part, which as a result will have either beer or juice, and then that result will be assigned to the drink variable. And so let's log it to the console now, just to make sure that everything is working again. And indeed, it says beer. 14, of course, he will drink juice. Now just to compare what we would have to do without the ternary operator, let's write out the same thing with an if-else statement. So we would have to write, so var drink equals beer in this case, and then the else block, and then here the juice. Okay, so that would be the alternative here of using this. And so what do you think looks better? Well, it's obviously the ternary operator, right? At least I prefer it very much about having to write something like this in case that we want something as simple as just assigning a value to a variable based on a simple condition like this. Okay, so of course you're not going to do a ternary operator for a rather complex decision, but in case that we have something simple like this, well, it is perfect to not have to use an if-else statement like this. So let me comment out this part here just so you know that this is the same. And all right, so we talked about the ternary operator as an alternative way of writing conditionals, but there is actually even more, and that is the switch statement. And this is like a huge if-else statement where we have multiple else-if clauses basically, and so we can replace that with an easier to understand syntax, okay? Now, I'm not a big fan of this myself, but you will see it around when you search for like tutorials on the web, and so it's important that you also know the switch statement. So let's add some comments here before we start. So the ternary operator, and then the switch statement. All right, so let's define a job here first. And let's say that John is a teacher. And so now we can use the switch statement. Give us some more space here. All right, so we say switch, and then here between these parentheses, we put what we want to test, what we want to evaluate. Okay, and this will make a lot more sense after you see the entire switch statement. So for now, just let's write the job here, and you will then understand why it works like this. So we switch the job basically, and then we can add a couple of case clauses. So we say case, and then we can say, for example, teacher, then the colon, and then in the next line, we say what we want to happen. So in this case, let's say first name teaches kids how to code. So that's what a teacher does, let's say. So again, if the job is equal to teacher, then this code here will be executed. All right, let's add a couple of more. So case driver, let's say, and now I'm just going to grab this piece of code here. Let's say a driver drives an Uber in Lisbon. And so this is the basic functionality of the switch statement. Okay, So we can add a couple of more cases even. So let's say we also want designer. And then again, our console.log, let's say designs beautiful websites. All right, so what we're doing here is again to compare the job to each of these different cases. So if the job is teacher, then do this. If the job is driver, then do this. If the job is designer, well, then do this. Now, what we have to do here also is to add a break statement. So in here, we have to say break because otherwise it will keep evaluating these next cases. Okay, so even if the job is teacher, it will then keep evaluating these other cases. It will keep basically looking at them and see if they are also true. But we don't want that to happen. And so we have to use the break keyword at the end of this block that we want to execute. So break, and here break also. Now, if none of these here applies, we can then add a default. Okay, so all we have to do is to say default and then define what happens in that case. So in this case, well, let's just say that John does something else. And then here, of course, we don't need to break because it's already the last case here anyway. Okay, so if none of these applies, so these are basically like the else if in the if else statement. So in an if else statement, this would be if job equals teacher, then do this, else if driver, then do this here, else if designer, then do this, and then else do this, right? And so this default here is basically our last else in an if else statement. All right, so let's try it out. And so indeed, it now says that John teaches kids how to code because he is a teacher. Now, if we say that he's a driver, then of course, drives an Uber in Lisbon. Now let's say that he is a cop. And so now none of these applies. And so we should end up with John does something else. Great. Now we can also have multiple case clauses for the same piece of code that we want to execute. So for example, if we want to execute this code here, if the job is a teacher, or also let's say instructor, then we can add simply another case here. So case instructor, and then this piece of code here will also be executed if we say instructor. Just to finish, let's try out that. And yeah, so it still works here as it should. So this is here again a simple way of replacing a huge if-else statement. For example, something like this, where we have this if and then else if, and then else, or it could be even longer. And so sometimes a switch statement looks a bit cleaner than having all of these blocks like this. Okay, and actually, since we're working on it, let's actually go ahead, copy this piece of code and try to replace this if-else statement here with a switch, because that's actually going to work in a slightly different way. And so it's a great opportunity to show you how that could work. So this first switch that I showed you here basically simply switches a variable and compares all of these cases to that variable. But here we have these number ranges, and so it works slightly different. And so it's a great exercise to do this one here as well. So to translate it basically to a switch statement. So in this case, what we want to switch is true. Okay, so we basically want to compare each of the expressions below that we're going to put here in a second to true. And this is a trick to simply make the switch work as an if-else statement with ranges. So our first case will be case age less than 13. And in that case, it will then log this piece to the console, and then don't forget the break. Okay, then the next case is this one, and let's actually go ahead and copy it because we already know how it works at this point. And then log this here to the console so that John is a teenager, and then let's break out of it. So let's complete the code here and then take a closer look at it and see how it works. Okay, so for this case, we want to log this part here to the console, then break out of it. And now finally, we have the else part here. And so for the else part, we are going to use, such as before, the default. So default, and then log that John is a man. All right, and so that's actually it. So we can get rid of this. And so we already translated it here to the switch statement. So we now have all of these conditions here, basically not as strings as we had before. So in this case here, and this is the more usual case of using the switch statement, okay? So where we have like a string that we want to compare with some variable. In this case here, we have basically these logical expressions here that will turn out to be either true or false. And so for example, if this here turns out to be true, so if the age is between 13 and 20, well, then this here is true and all of the others are false. And remember that we switched true. And so the case that will be true will then be the one that is executed. Okay, so let's try that out. And the age I think is not, actually it is defined as 14. Let's put it again here, so we don't have to go up and down to test this. So let's say that he is 10 now. And so let's check it out. So John is a boy. Great. Change it to 17. Now he's a teenager. Now 22 again, a young man, and a man. So all of these now work. So these are two ways of using switch statements, and they can be useful again in case that we have a long if-else statement with lots of else-ifs. So this can look a bit cleaner here. All right, and so that's 3 ways in which we can write conditional code. So the if-else statement, the ternary operator, and the switch statement. Before we can move on to our next big topic, we need to quickly learn about something called truthy and falsy values. So in JavaScript, a falsy value is a value that is considered false when evaluated in an if-else statement condition. And the values that are falsy in JavaScript are undefined, null, 0, empty strings, and not a number values. So let me actually write that down for you, okay? So falsy values, they are undefined, null, 0, empty strings, and not a number. So we didn't talk about this here yet, but you will see examples of this here later in the course, okay? So all of these 5 different values here will be converted to false when evaluated in a true-false condition, okay? And so that's why we call them falsy. They are not exactly false, but they will turn out to be false when evaluated in a if-else condition. Now we also have truthy values. And of course the truthy values are all the values that are considered true when evaluated in an if-else statement condition. And so basically it's all the values that are not falsy. Okay, so let's now take a look at an example to demonstrate how this works. Okay. So let's define a variable of height, let's say, and we will not actually define it. So we just declare it here. And now let's write an if-else statement. So we can say if height, and then log to the console the variable is defined, and else the variable has not been defined. So let's see what happens here. And what we get printed is that the variable has not been defined. And so why is that happening? Well, we declared the variable here as height, but we didn't define it. And so you already know that it's now undefined. And we also know that undefined is a falsy value, right? And so in here, when we say if height, then this height here is converted to false. And so therefore we enter the else block, which will then print that the variable hasn't been defined yet. And so this is a very handy way of testing if a variable has actually been defined or not. Okay, and now let's say that we actually do define a value. So let's say 23. And so watch what happens now. And so, of course, the variable is now defined, okay? And so that's because everything that is not a falsy value is a truthy value. And so we already know that when a variable exists, well, then this here will be converted to true, and therefore the if block here is entered. Okay, so again, a very handy way of testing if a variable actually exists. Now there's just one thing to keep in mind here, and that is that notice how this 0 also is a falsy value. But the height can of course be 0. So let's set it to 0 here. And so the variable is actually defined now, isn't it? So we have a value here. It's not undefined. But if we now reload this, well, then it still says that the variable has not been defined. And so that's of course a situation that we want to avoid. So this here can not only be height, but we also have to say that if the variable is 0, well then the variable is also defined. Okay, and remember that we can use the OR operator to do exactly that. So we already used the AND operator before, but we also talked about the OR operator. And so we can say OR, the height is equal to 0. Okay, and so that will fix the problem. And this is quite a common pattern in JavaScript to check if a variable is defined. So we check if the variable exists or if it is equal to 0. And then the if block here is in fact entered. Okay, so let's check that out again. And so now we see that the variable is defined. Okay, and remember that only one of these here has to be true in order for the entire condition to be true. Okay, so in this case now the height is 0, and so this here will be converted to false. Okay, but we then have height equal to 0, which is true, of course, because in this situation the height is 0. And so we have false and true, which will result in true. And so therefore this line of code here is then executed. All right, and now this is going to work with any number here and also with strings. So let's say 20, for example. And you see that it's still true because it still entered that first block. But if we have an empty string, remember that also is a falsy value as we see here. So with an empty string, it now says the variable has not been defined again. And so that kind of makes sense, right? Because in fact, there's not really something there. It's just like an empty string. Okay, so these are falsy and truthy values and a handy way to check if a variable is actually defined. Now, just to finish, let's talk about the two different equality operators. So we've always used this triple equal operator, right? And this is the one for strict equality comparisons. But there's also the equal equal. So this operator here, and the difference is that this one does type coercion, which means that the data types of both variables do not have to match. Okay, so let me show that to you actually in practice. So just a comment here, and now let's say if height equals 23, so we have a string now here, then let's simply log to the console the equal equal operator does type coercion. Okay, and so let's check out what happens. And before we do that, let's set this here back to 23. Okay, so what we're doing here is to compare the height, which is 23, a number, with the string of 23 with the non-strict equality operator, which is this one. So only two equals. So let's take a look at this. And so you see that this actually turns out to be true. And so we enter this first if block. And so you see the equal equal operator does type coercion. So what this means is that JavaScript, when we use this operator here, converts the string of 23 to a number and then says that it's the same as 23, the number. So let's take a look at that here again. So 23 and then the string 23, and it will say that it is true. Okay, so exactly what we observed in here. So again, JavaScript does type coercion, which basically means to convert the string here to a number and then compares the numbers, and then of course they are the same, right? Now, if instead we use the strict equality operator with the 3 equal signs, well, then it will not do type coercion. And so therefore, what do you think will happen now? Yes, indeed, it now says that it's false, because in fact, they are two different things. So we have 23 the number and 23 the string, and they are different things. And so in fact, we want them not to be the same. Okay? And so if instead we had the 3 equals here, well, then of course, we will not see this output here. We will not see this log to the console because it's false. Okay? So that is how the strict equality operator works. And it is absolutely a best practice to always use the triple equal, so the strict equality operator, in order to avoid unexpected situations and bugs. So that's why I've been using this operator all the time with the 3 equals and not just the 2 equals. So after learning all about conditionals and true-false values in JavaScript, it's now time for another coding challenge. So let's say John and Mike both play basketball, but in different teams. And in the latest 3 games, John's team has scored 89, 120, and 103 points. And Mike's team has scored 116, 94, and 123 points. Okay? And what I want you to do is to calculate the average score for each team, Then decide which teams wins in average, so the one that has the highest average score, and then print the winner to the console. And when you print that winner to the console, then also include the average score. Okay, so we already calculated averages before, so all you have to do is to add up all the values and then divide by 3 in this case, because we have 3 results here. Okay, and then what I also want you to do is to change the scores in order to show different winners. Okay, and so here, don't forget to take into account that there might be a draw. So it means that there is the same average score. And so in your if-else statement, you will have to keep that in mind. Okay, now after you finish that, you can take it to the next level and add a little extra. And in this case, Mary also plays basketball, and her team has scored 97, 134, and 105 points. And like before, I want you to log the average winner to the console. So what you're going to have to do here is to check if one of the players has a larger score than the other two. Okay, and in order to do that, you will probably need the AND operator to take that decision. Okay, and if you cannot solve this one, then it's absolutely no problem. You can just watch the solution and see how I do it in there. Okay, the most important thing is that you can do these number 1, 2, and 3. Okay, then if you want to take it to the next level here with the number 4, then that's also a great addition to this challenge. Okay, so take a couple of minutes here, maybe half an hour, and try to really complete this challenge, and then I'll see you in the next video with the solution. So here goes my solution to coding challenge number 2. So let's start by calculating the average scores. So var score John is equal to, and we have the points, so 89 plus 120 plus 103 divided by 3. Then var score Mike is equal to 116 plus 94 plus 123 divided by 3 again. And now let's simply log these to the console. Score John and score Mike. And here we go. So the average score for John 104 and for Mike 111. So Mike is clearly the winner here. And so let's now log that to the console. Okay, and so what we're going to do here is, of course, an if-else statement. So give it some space here. And now, if score John is greater than score Mike, well, then log to the console that John's, now we need to escape this quote here. So John's team wins with, and now let's also include the score here, as I mentioned in the instructions. So score John points. All right. And else if it's the other way around, basically, so score Mike is greater than score John, well, then let's of course log that Mike's team wins. Then here we also need to use the score of Mike. Okay, and then else, and that's the situation where there is a draw. So if John's score is not greater than Mike's, and Mike's score is also not greater than John, well then it means that they have the same score. Okay, and so that is here this else block. And so in here we can simply log that there is a draw. So let's test it out. And so yeah, Mike's team wins with 111 points. Let's now increase this here, let's say to 129. And so now probably John wins. And yeah, here we go. So now John's team wins. Now let's try to have a tie here. So we had 89 before. Let's put it to 95. And we need some more points here. So let's increase this to 115. That was a bit too much. 112 maybe. And now we're almost there, I guess. Yeah, so now they have the same scores, so both have 111, and so now we see that there is a draw. And so, of course, none of these situations here apply, because John's score is not greater than Mike's score, and Mike's score is not greater than John's score. And so, of course, we have a draw. So that is the easier part. Now let's also add Mary to the game. So, var score Mary equals, and let's get her points. So 97, 134, and 105. This should be a comma, obviously, and this should be plus signs, of course. Sorry for that. So we add all of them together and then divide it by 3. Also log it to the console just to make sure. So she has 112. And here let's put back what we had initially. So it was, 89. And so now we have these 3 different scores. All right, so let's get rid of this part, and I'm not going to delete it. I'll just comment it out. And okay, so how can John win the game? Basically, he has to have more points than Mike and also more points than Mary, right? And so that's what we have to translate into code now. So an if-else statement, and we have to say that score John should be greater than score Mike, and score John should be greater than score Mary. Okay, and that's it. So, does that make sense? That is a great use case of the AND operator here. And it works like this because we need this here to be true, and at the same time, we need this to be true. So John's score needs to be greater than both Mary's and Mike's. All right, and so only in that case, we will want to print that John's team wins the game. And then from here, it's actually pretty straightforward. So once we understand how the logic works, all we have to do is to do the same for the other players. So how does Mike win the game? Well, of course, he has to have a larger score than the other two. So score Mike needs to be greater than score John. And at the same time, score Mike, and what happened here? So score Mike greater than score Mary. So John, and here we have Mike, and of course score Mike. And then finally, the same for Mary. So score Mary needs to be larger than score John, and score Mary greater than score Mike. And now we say that Mary's teams win, and here the score Mary. All right. Now, what about the other situations? Well, let's just use an else here and say that there is a draw. Okay, so this doesn't really cover all the different situations here, but that's not a big deal. So for this small example, it's okay. Imagine that Mary and John had both the same score, but a larger score than Mike. So they two would have a tie, but would still have more points than Mike. And so that's one of the situations in which we will enter this else block and display that there is a draw. Okay, so these 3 situations here only work for a clear winner. All right, but again, that's not a big deal. We don't need to cover every single situation here. So these are the more important, of course, where we can define which one is the clear winner. So let's try it out now. And indeed, Mary's team wins with 112 points. Let's add some points here to Mike. And if we add 3 points, then he will have the same score as Mary. So let's put this to 19 here. And they now have both 112. And so we see that there is a draw. So perfect. And if we now increase this even further, let's say 29, well then of course Mike's team has the most point. And now finally let's add some more points here to John just to test if all 3 cases work. And indeed, now he has the most points and he is declared the winner. Great, so that's it. I hope you figured it out. And so now you are really ready to finally move on to the next part of this intro section, which is the hugely important topic of functions. So join me right there in the next video. Welcome back to one of the most fundamental concepts in JavaScript, and that is functions. So if we have a piece of code that we want to run a lot of times, we can put that into a function instead of writing it over and over again, okay? So functions are like containers that hold some lines of code, and we can pass arguments into them, and they can then return us a result. And instead of talking more about this, let me actually show you a very small and very simple example. So this is how we write functions. We simply write function, and then we give the function a name. So just like a variable, we have to give a function also a name. And in this case, what we want to do is to calculate an age. So calculate age. And as I mentioned before, we can pass something called arguments into a function. And so we open up parentheses, and then we say the argument that we want to pass in. And what we want to pass is called birth year. Okay, and so this will kind of be like a variable inside of the function. All right, but more on that a bit later. So we say function, then the name of the function, then the argument that we want to pass into the function, and then finally the curly braces in order to write the function block. So all the code that is in here will be the function block. Now we can of course also pass 0 arguments into this, or we can also pass multiple. So we could pass more like x and y separated by commas like this, but in this case we only want one argument, which is the birth year. All right, so we pass in the birth year, and then we can return something from the function. So in this case, what we want to return is the age of the person. So we calculate it by doing 2018 minus the year in which the person was born. And so we can now basically use this variable inside of the function. Okay, so this birth year parameter that we defined here in this function definition up here. So I like to think of a function as like a machine that receives some input, then it does some stuff with it, and finally returns something else. So something new created from the data that we put in. So that is our function definition. Now let's actually go ahead and use this function. Okay, so to call this. So we can say now calculate age, then we open the parentheses, and now is the time where we pass in that argument. So let's say that we want to pass in 1990, and so like this, we will call the function. And the function will then take this value, this 1990, as the birth year. So this is now 1990, and then we will do this calculations, 2018 minus that birth year, so in this case minus 1990, and will then return a result, okay? And so that result, we have to store it somewhere. So let's create a new variable for that, age John. And so in age John here will be stored the result of calling this calculate age function. All right, so test that out and log age John to console. And here we go. So 28 years old. And that makes total sense because it's 2018 minus 1990. So again, we define this parameter here, or this argument, and you will hear me saying these two words, and they're not exactly the same, okay? But for now, let's just keep it simple and assume that arguments and parameters are the same thing, okay? So we defined this argument here of birth year, and so when we call the function, calculate age down here, and we pass in the value, then this birth year variable here, or argument, will be assigned that value that we pass in. So 1990 in this case. And then inside the function, we can use that. All right. So let's now calculate some more ages. So let me copy this here. And so we want age Mike, let's say 1948, and age, let's say Jane now, so a new person here, 1969. All right, and now we can log all of these to the console. And so let's see. So 28, 70, and 49. And so now you start seeing the power of the function, because instead of having to write that same code here over and over again, we can simply always call the same function. Now in this case, it would probably not be so problematic to write this code. It's just one line, but of course functions can be huge. They can be much bigger than this. And so then it of course becomes a lot more useful. And so functions are very, very important for one of the most important programming principles, which is called don't repeat yourself, or DRY. Okay, so the dry principle is something really important in programming as general. So you should never repeat yourself, never write the same code, and instead put it into a function. And so that's why we have functions in JavaScript and in all programming languages in general. So that was just a very simple example of a very, very simple function. So let's now add some more complexity to it. And let's create a new function which will calculate the years until retirement. So based on our birth year, we will be able to calculate how many years we have left until we retire. So that's a little bit more complex, and so it's a good use case for a function. So years until retirement. And now let's pass in the birth year just as before, and also the first name. So as I mentioned, we can pass multiple things into a function, not just one argument. We can pass 2 arguments, or 0, or 3, 4, and as many as we want really. So how are we going to calculate the years until retirement? Well, first of all, we need to calculate the age. And so now let's actually call the other function that we already coded before. And so what this means is that functions can actually also call other functions. All right. And so let's calculate the age based on the birth year again. Okay. And maybe let's give it here another name so that it's not so confusing. So I'm just calling this year now here. Okay. And if I change it up here, then of course I also have to change it here. All right. And so when we now call this function, this years until retirement, then we pass in an argument as the year, let's say 1990, and that will then be passed into calculate age. So 1990 again, and that in turn will then be passed into the calculate age function here and can be used to return the age. All right. And so that age will then be stored in this variable, and then we can calculate the retirement. So the retirement is the age at which we retire minus our current age. So let's say that we retire at 65 years. So that's kind of a standard, I guess, at this time. And then minus the age. And that gives us how many years we have left until retirement. Okay, now functions don't always have to return something. So up here we return something so that we can then use the value later. But in this case, we don't want to return anything. We can simply log something to the console. So we want to say first name retires in, and then the retirement plus years. Okay, so that's our function. And let's now call it. So years until retirement. Let's again use the year of 1990, and then the first name is John. Okay, and this time we are not saving the result anywhere because there is not really a result. So that's what I just mentioned before. There is no return here in this function, and so there's no result, and so we don't have to store any result anywhere. So if we just now call this function like this, then all that's going to happen is that these calculations will be done, and then we will log something to the console. So let's check that out. And so John retires in 37 years. So let's quickly recap what happened here. We passed in 2 arguments, 1990, which is now called year inside of this function, and we also passed in this string called John, which will be called first name inside of that function. And so in our console.log, we use that first name here, which is John, and then also the year is used to calculate the age. And that age calculation is, as I mentioned before, done using the calculate age function that we coded up before up here. Okay, so functions can call other functions. They also do not have to return anything. It's quite usual that they do, but of course they don't always have to. All right, so let's now do this with some other years, and we can actually use the same as before. And probably it's easier to just write it out. So 1969, and here we have Mike, and then also Jane. And so now you have John retires 37 minus 5 and 16. And so hopefully by now you see even better how handy it is to have all this code here in one function. Because imagine how repetitive it would be to have to write this for each of these persons, right? Instead, we just put all of this code in one function and therefore keep our code dry. So dry, remember, means don't repeat yourself. Okay, now just one thing that I see here is that we have minus 5 years here, and what that means is that this person, Mike in this case, is already retired. Okay, so let's add a simple if-else statement here. So if the retirement is greater than 0, well, in this case, it means that we still have some years left to retire, and then we want to log this to the console. But else, so basically if the retirement is 0 or less, it means that we are already retired. So let's log that to the console. First name is already retired. So check that out. And so Mike is already retired, it says now, instead of what it had before. All right, great. So these are the fundamentals of functions, which again are one of the most fundamental principles in all programming and of course also in JavaScript. All right. So what you have to keep in mind here, just to recap, is that we can pass in arguments into a function like this and like this, like we see here. Then we can return results from a function using the return keyword, and we can then save these results into variables like we did here. Also, functions can call other functions like we did here, and they do not need to return something, so it's not mandatory. All right, so that's the fundamentals of functions. Next up, let's talk about something called function expressions and function declarations. In this video, you will learn about function statements and expressions. So in the last video, where we first talked about functions, I always declared functions using function statements. But there's actually another way of writing functions in JavaScript, and that is by using function expressions. Okay? So all the logic of functions that I explained to you in the last lecture still work the exact same way. We just write the function in a slightly different way. And under the hood of JavaScript, it also works quite differently actually, but for now, that's not important for us. I just want you to know at this point that we have both function statements and expressions. So let me show it to you. And so when we write a function expression, we start by writing the function basically without a name. So we still use the function keyword, and then right after that, we put the arguments list. And so in this case, I want to pass in the job and the first name. Okay, and only then we basically assign this function to a variable. So we declare a variable, and this one I'm going to call what do you do. So basically it's a function where we pass in the job, and then the function tells us what that person does. So what do you do? So that is now a variable, and what we assign to that variable is simply this function. So function where we pass in job and first name, and then of course the function block. All right, so comparing that to what we had before, or actually let's write it out here. So that is a function expression. And if we did the same thing as a function declaration, then we would write function, what do you do, and then the arguments list. So something like this. Okay, so you see the difference? Okay, so let me comment this out here. So this is just so you know what the difference between a declaration and an expression is. And again, the way that we call the function and the way that we pass in the parameters and all that stuff that you learned before still works the exact same way with function expressions. All right, so let's now use a switch statement here so that you can practice some different stuff that we learned before. And we will do something similar to the switch that we had before actually. So we're going to switch the job here, and then our different cases will be for, let's say, teacher. And let's add the cases here before. So case teacher, then we have driver, then we have designer, and then finally the default case if none of the before apply. All right. Now, the other time where we did this similar switch, we had a console.log and then a break. But this time we're going to actually return something. So let's say we want to return first name plus the string that we had before. So teaches kids how to code. Okay, and now we will actually not have to include the break. That is because of something that I didn't tell you before. That is, when we hit the return keyword here, then we return whatever we define after it. But what also happens is that the function immediately finishes. So basically we immediately go out of the function and return to the place where we actually called the function. Okay, so the return keyword does not only return the value, but it also immediately finishes the function. Okay, so we do not need the break here. So in case that the job is teacher, then we return this string here and then immediately exit the function. All right, now in case that the job is a driver, well, then we return something else. Okay, and so in that case, this line here is never executed, obviously, and so it's not going to finish the function, and instead it will come to this next case, which is driver. So first name, and let's say drives a cab in Lisbon. Then the same thing for the designer. Designs beautiful websites. And then finally the default case. Does something else. Okay, so let's now give it a try. So just like before, we call our function, what do you do? And then we pass in the job and the first name. So let's pass in teacher. And of course, John. And don't forget that this function here returns something, and so we should save that somewhere. All right, or instead of saving it, we can of course also simply log it to the console. So let's do that instead. Okay, so that's something that we didn't do before. So immediately log to the console the result of calling this function. Okay, but that just works the same. So in this case, what we will return here is the string John teaches kids how to code, right? And so that will then be logged to the console. So exactly like I said, this is the string that we expected, right? And now, of course, we can do this multiple times. So let's say designer, Jane, and then, well, we can say that Mark is retired. Let's see what happens now. So Jane designs beautiful websites, and then Mark does something else, which is the default clause here. So again, you see how useful it is to be able to reuse all of this code. Otherwise, we would have to basically write this here 3 times if we wanted to have this scenario with 3 people and 3 different jobs. And like this, we simply pass to the function the things that change, basically. So what's different here is the job and the name for each of these cases. And so that's what we passed into the function, both the job and the name. And then based on that, the function does something, which is in this case, produce a string and then returns it. So again, we can always see a function like a machine that receives something, then does something with the data and gives back something different. Okay, so this is how we write a function expression. Now, statements and expressions, they do not only apply to functions, but they are a global concept in JavaScript actually. So before moving on, let's talk a bit about the difference between statements and expressions. So JavaScript expressions are pieces of code that always produce a value. And it doesn't matter how long they are, as long as the code results in a single value, and then it is an expression. So let's take a look at that in the console here. And so, for example, if we simply write 2 plus 3, well, then you see that this produces a result, so 5 in this case. And so what we just wrote here is a JavaScript expression, okay? And the same is when we, for example, call this function. So let's call this function right here in the console, and we actually have access to these functions here right in the console, okay? So that's something that we didn't do up until this point, basically using the variables and functions that we define here in our code right in our console, but we can do that, okay? And so when we now call this function here, then you see that, of course, it returns a value. And so again, this function call here is an expression. And really anything that we do, again, that produces a result is an expression. So for example, type of 23, and it gives us back this result of number. And so again, this is an expression, all right? So what this means is that whenever JavaScript expects a value, we always have to write an expression. Okay, and the importance of this whole concept might be a bit hard to grasp at this point for you, okay? But it's really important to learn this stuff for the future, all right? So for example, here in this if-else statement, for example here, JavaScript, of course, expects a value here. And so this here needs to be an expression. And of course it is, because this operator here will, of course, return true or false. And so that is a result. And so therefore it's an expression. Okay. Now, anyway, about statements, they do just perform actions. So they do things, but they do not produce immediate results. So these are things like if-else statements, a while loop that we're going to talk about later, or even a function declaration. They don't produce any immediate value, and so they are called statements. So let's again take a look at that here in the console. And I'm going to write a very simple if-else statement here. So let's say if true, and so this if block here will of course be entered. So let's write console.log here of just some numbers, some random stuff. So it doesn't really matter here. And so let's hit return. And you see now here that what this returns is undefined. Okay, so it doesn't really return anything. But this 23 here simply comes from this console.log here. But the statement itself, it does not return anything. So it's just really this statement that doesn't produce a result. And so that's the difference between expressions and statement. All right, so coming back to functions here, we learned that function expressions produce an immediate result, while function declarations do not. And this will actually be very important for certain situations that you're going to learn about later in the course. So in these two lectures, we covered the very basics of functions, but of course there's a whole lot more to learn about functions. But again, I will leave that for a bit later in the course, so that we're now ready to move on to another huge and exciting topic, that is arrays. Arrays are a fundamental concept in JavaScript that you're going to use throughout your entire JavaScript life. Okay, so let's now learn exactly how they work. So in many previous lectures, we had different variables for different persons. But now imagine how handy it would be to bundle them all into one single variable. And in JavaScript, we have arrays for that. They're like collections of variables that can even have different data types. Okay. So let's declare a variable, like always, called names, and now we can use an array. And there are different ways of creating a new array, but the easiest and most used one is using brackets. So we use the brackets, and then in here we put our different values. So let's say we want an array of names. So John, then comma, and then we add a new element. So Mark, and then let's say a third element called Jane. All right, so now we have an array of names, an array with 3 elements called John, Mark, and Jane, all separated by these commas. Okay, so let's create a new one called years. And as I mentioned, there are different ways of creating arrays. So let's see another one, which is new array. So you can do an array like this, basically calling this array function here with the new keyword, and then in there you pass the data that you want to be in the array. So 1990, 1969, and 1948. All right, so this will be an array the same, but again, this here is far more used, and so you will usually not use this one, okay? I just wanted to let you know that it also exists. Now, we say that arrays are zero-based, which means that the first element is element number 0, the second one is element number 1, number 2, and so forth and so on. Okay, so let's now see how we can actually access elements in an array. So we're going to log to the console, names, and then we use the brackets again, and then the index, so the number. Okay, and so names brackets 0 will be the element 0 of the names array. And remember that arrays are zero-based, and so John is the element 0. So let's take a look at that, and indeed, we see John. Of course, we could also log the entire array. So this is how it's going to look like. So we have here, we say number 3, which is the amount of elements in the array, and then the entire array. And actually, we can also access this number here. And all we have to do in order to do that is to say names dot length. Okay, so we will learn later what this dot here means, but for now, just know that we can do names dot length, and then that will show us how many elements are in there. In this case, it just returned undefined, but that is just because I misspelled length. Okay, so that's what it should look like, and now we should get the number 3. So we have 3 elements in our array. Okay, so we access number 0, we can also access number 2, for example, and that should be then Jane. Okay, so this is how we retrieve basically data from the array. But we can also use the syntax to mutate the data in the array. Okay, so we can say names and 1, which will be Mark, and then we can say that we want it to be Ben instead of Mark. Okay, and so if we now log the array, then we should see that it's different. And so now it is actually on position number 1, it is Ben and no longer Mark. Okay, we can also add data to the array. So we can actually access a position that's not even there. So let's say we want position 5 to be Mary. So let's see what happens then. And actually let's put it here before this console.log. And so you see that now we have empty here, and then only then comes Mary. Now if we wanted to add the Mary as the last element in the array, we could use this property that we used before, so names.length. So remember that this is 3 at this point. If we say names.length, and this will then be 3, and so names 3 should be Mary. And so then it adds this as the last element in the array basically. Okay, makes sense? So first, let me actually edit here. So muted array data. Here we can say initialize new array. Okay, so first here we mutated the array on position number 1 and added Ben. Then here we mutate the array at position number names.length, and that is 3 at this point. Okay, and so at names position number 3 we will add Mary, and so position number 3 will be the last one. So 0, 1, 2, and then 3 is the new one. Okay, so I hope that you start to see how useful arrays can be by holding this different data all in one variable. And of course this can also be different data types. So let's say that we want to have all the information about John all in one variable. Okay, let's give us some more space here, and then let's say var John, and now we can put the first name, we can put the last name, we can put the date of birth, we can put the job, and we can put that he is single or that he's not married. So let's say false. Okay, so now we have different data type all in one data structure, which is this array. All right, so these are the very basics of arrays, but let's make it a bit better even, because there are a couple of functions that we can basically apply to arrays. And these functions are called methods that are specific to arrays. And you will learn all about methods and why they are called methods in this case in the next couple of lectures. All right, for now just know that we can do something like this. So we have our John variable, and then we can say dot push, and then this is like a regular function. And the push function, or the push method, what it will do is that it will add an element at the end of the array. So let's say that John's favorite color is blue. And so if we pass in blue now here, it will then add that element to the end of the array. All right, so console.log John, and so let's see how that worked. And so indeed, we have now the array that we declared initially plus the blue element at the end of the array. So that's what the push method, the push function here, did to the John array. All right, so don't worry about this dot syntax here and this function, this way we call this push function. We will learn about why it works this way in a couple of lectures. So there are a couple of methods that I want to show you now, because push is not the only one. There are tons of different methods for arrays, and I will just show you a couple of them now. So we can also use John unshift. And what unshift will do is very similar to push, but instead of adding to the end of the array, it will add it to the beginning. So let's say that we want to add a title, so Mr., so that it's Mr. John Smith. And so now we have the first element, the Mr., and then the rest, as we've seen in the previous steps. So these two methods here, they add elements to the array, let's now see two methods that remove them. So John.pop, and what this will do is that it removes the element from the end. All right, so let's now then log it to the console again. And so now you see that we have the array from before, but without the blue element. And if we do it again, then it will remove yet another from the end. And so now we should also lose the false. So let's take a look at that. And indeed, it did now remove these two. Okay. And so finally, we also have a method, of course, to remove the first element. And that one is called shift. Okay, and so now we should lose the mister here. And yeah, indeed it's gone. Okay, so push and shift, pop and shift methods. And now just one last that I want to show you, which is the index of. All right, so let me show that to you. So index of will return the position of the argument that we pass in inside of this array. So let's say that we want to know the position of the 1990. So we pass in this value, and index of will then return in which position this 1990 appears in the John array. So let's log that to the console so we can take a look at it. And so what do you think it will be? So take a guess, and now let's see. And it is number 2, and indeed it is. So 0, 1, and 2. Okay, so it returns the position at which the element is in the array, if it is in the array, and if that element is actually not present in the array, it will return -1. So let's say that we pass in something else, let's say 23, and so now it should return -1. And indeed it does, because we don't have any 23 in that array. And so one of the things that this method here is most useful for is to actually test if an element is in the array or not. So let me show that to you. And so let's use the ternary operator that we learned about before. So John.index of, and so now let's test if John is a designer. So we ask the position of the designer element in the array. So that will return a number to us. And then we say, if it's equal to -1, well, then John is not a designer. And else, John is a designer. All right. So let's check that out. And nothing happens, of course, because we didn't assign this here to any variable. So let's say var is designer. And then we can log it to the console. Okay, so John is not a designer. So let's see why that happened. So we searched for designer in the array, but that element is not actually in that array. And so it will return -1. So this entire part here will be -1. And so we test, is -1 equal to -1? And yeah, indeed it is. And so the isDesigner variable will be assigned the John is not a designer string. Okay, so let's say we now change it to designer. And so now we should see that John is a designer, because it will now actually return this index. Let's try that out in the console. So index of, and you see that it is 3. All right, so 0, 1, 2, and 3. And so 3 is of course different than -1. And so we now have John is a designer. Okay, so these are just a couple of methods on arrays, and I'm going to show you many more throughout the rest of the course. But for now, you know how arrays work, and that's amazing. It's a really powerful data structure that we can use in JavaScript. And so now I think that you learned enough already to take on another coding challenge. So let's do that right in the next video. Welcome to the next coding challenge. In this one, you're going to build a very simple tip calculator. So John and his family went on a holiday and went to 3 different restaurants. And the bills were $124, $48, and $268. Now, to tip the waiter a fair amount, John created a simple tip calculator as a function. And the way that John calculates his tips is that he likes to tip 20% of the bill when the bill is less than $50, 15% when the bill is between $50 and $200, and 10% of the bill if it is more than $200. And this may not make a lot of sense, but this is just for this small exercise, so we have some more stuff to do in our function. Okay, so in the end, John would then like to have two arrays as the end results. So one containing all three tips, so one for each bill, and then one containing all three final paid amounts. And with paid amounts, I mean the bill plus the paid tip. Okay, so we want a function that calculates the tip, and then we want two arrays, one with just the tips and one with tips plus the bill. Okay, and if you're not sure how to calculate a percentage, for example, if you want to take 20% of a value, you have to simply multiply that value by 0.2, which is 20 divided by 100. Okay, so that's very simple. All right, so I hope you managed to do this. This will be a good challenge for you to use most of the stuff that we talked about up until this point. So give it some time, try it out, and then I see you in the next video with the solution. Good luck! So I really hope that you gave the challenge a try, and of course that you managed to do it. So here goes my solution in case you're wondering how I did it. I'm going to start by creating the tip calculator function. Okay, so function, and I'm going to call it tip calculator. Then in here you pass a value, which I call the bill, and then we have our function body. Okay, now we want to, depending on the bill value, to determine the percentage of the tip that John likes to pay. Okay, so here we have our rules again. So 20% if the bill is less than $50, 15% if it's between 50 and 200, and then 10% if the bill is more than 200. So I'm going to define var percentage here, and then I'm going to leave it. And now in an if-else statement is where I'm actually going to define the value for the percentage depending on the bill. So if the bill is less than 50, then the percentage should be 20. Or actually it should be 0.2. So we could write 0.2, but we don't even need the 0 here. So just 0.2, because that's actually the value that later we are going to multiply with the bill. Okay, so remember, to calculate 20% of a value, we multiply it by 0.2 in this case, because that's 20 divided by 100. All right, so else if the bill is greater or equal to 50, and if the bill is less than 200. So that's very similar to the stuff that we already did before, right? And so this should be nothing new for you at this point. So in this case, our percentage is going to be 0.15, and else the percentage will be 0.0, or actually 0.1, sorry. So 0.1, which is 10%. Okay, and in this case, we don't even have to specify the if here, because if the bill is not less than 50 and not between 50 and 200, well, then that means that it's more than 200. And so this case here covers all of that. Okay, and so all we have to do now is to return this percentage times the bill. Okay, and so for example, if our bill was $100, then we would divide it with 0.15, which would then be $15. And so we would return $15 from this tip calculator function. All right, now you could of course have done this differently. For example, you could have done a switch like we did before. For example, where is it? So something very similar to, I'm not sure where, yeah, so here is it. So you could have done something similar to this one here, for example, as well, where in each case you would then return the bill times the current percentage. Okay, but it works fine just like this, okay? So just to tell that there are always different solutions for the same problems, okay? And now I just want to actually test this here with some value. So tip calculator, and let's set it to 100, and we need to console.log it. So again, this is just for testing to see if our function is actually working just fine. So this here should return 15, right? And indeed it does. Okay, so that's 15% of 100, which is between 50 and 200. Okay, now let's try it with 300, and we're going to take 10% of that, which should be 30. So Let's test, and indeed it works. And now let's put, let's say $10, which is of course less than 50, and so 2% of that should be $2. And yeah, indeed it is 2. And so that means that our tip calculator is actually working. So all we have to do now is to create these two arrays that John wants as a result. So the first thing I'm going to do is to actually store the builds into an array. So we have 124, we have 48, and then 268, I believe. Let's just confirm that. And yeah, so these are the builds that we have. And then let's calculate the tips actually. So the first tip is calculated by using tip calculator with the builds on position number 0, right? Then the second one, and actually let's put it in a separate line here. So the second one is tip calculator builds on element 1. And then finally, the last one is calculating the tip with builds at position number 2. Okay, so we just created an array here which contains these 3 values, which all come from the result of calculating the tip using our tip calculator function. All right, so let's log it to the console here. And so yeah, here we have our tips. Now this here is something weird that is happening with the 9.6 and 001. And this is something weird that JavaScript does with numbers, and no one really knows why this is happening. So it should just be 9.6. And the same is actually happening here with these 5999998. And this, of course, should be 18.6. Okay, but that's nothing we can change. That's not like our fault. So JavaScript just does these weird calculations here that do not really make sense. But so don't worry about them. Okay. So this is the first array that we want. So the 3 tips. And then finally we want one containing all 3 final paid amounts. And so that's also very easy. Let's say final values. So another array. And well, here we have to say builds at position 0 plus the tips at position 0. And that's it. So very simple. Let's just grab this here. And here it's 1. And here it's 2. And so this is actually all that we need to do in order to have our final results. Okay, and now you see that actually here, now we have this 0.6 and this 0.6 coming from these two. So this is really weird again, but yeah, don't worry about it. Anyway, what we really want to see here is that this 142.6 is really the sum of the original bill, which is 124 plus this 18.6. Okay, and the same of course for the others. So 57.6 is 9.6 plus 48, and the same here for this last element. And so with that, the challenge is completed. Okay. And you could have done it very differently, of course. For example, you could have declared empty arrays in the beginning and then used the push method to add all of these results to the array. But again, it's not really important that your code is the same as mine, okay? I cannot stress this enough. So what I really want you is to write code and to think about how to solve these problems. And if the results that you get are the same as mine, well then that's really fantastic. So you've come a long way in this section, but there's still a couple of more things to learn. So let's now move on. Welcome back. In this lecture, I will give you an introduction to objects, which is the single most important feature of the JavaScript language. So let's get started. So the arrays that we've been learning about are very useful and are, of course, very much used in JavaScript programming. But imagine that you wanted to access an element of the array, not by its index, but by a specific name. So basically naming each of the values. And with arrays, of course, you cannot do that, but you can with objects. So in objects, we define key value pairs, which means that each value has a name, which is called the key. So in simple terms, we can use objects to group together different variables that belong together and that have no particular order. just like, for example, the properties of John that we've been talking about in all these past lectures. So one fundamental difference between arrays and objects is that in arrays, the order matters a lot, while in objects, it does not matter at all. Okay, so let me actually show it to you how we can create an object. So we start again by defining a variable. And now the easiest way of creating a new object is with the so-called object literal, which is basically just like a container that we can fill with variables, which are called properties. So the object literal, we write it like this. So just curly braces, just like with arrays, we have the brackets. In objects, you have the curly braces. Okay, and so now we can start defining our key value pairs. So name, for example, and now John. Or we can also say first name, just like we've been doing all this time, so that we keep our naming consistent here. So here in this example, first name is now a key and John is the value. And so we call all of this here a key value pair. We also say that first name is a property of the John object. Okay, but a bit more on that later. So for now, let's keep defining a couple of key value pairs here so that I can show you then how we can access them and also mutate them, just like I showed you in arrays. Let's also define the last name. So Smith. And then just like in arrays, as you've seen here, we have to separate these different lines, so these different key value pairs with a comma. Okay. So birth year, and again 1990. And you see that we can put all kinds of different data types in here, just like before. We can even put arrays in here. So why not? Let's define a family property. And now we can put an array in here saying the family members. So let's say that some family members of John are Jane, Mark, so Bob, and Emily. So as you see inside the object, we can actually have other elements like this. So we can even have an array. We could even actually put another object inside of the object. All right. And actually the same is true for arrays. So we didn't talk about that in the arrays lecture, but as an array element, you can actually also have an object or another array or really whatever you want. All right. And of course, you will see examples of all that throughout the course. So don't worry. This is really just the intro section. We're going to use all of this stuff a bit later. So we can define a job, and now also let's define the is married state, just like before. So we say false. Okay, and then the last one has no comma or semicolon, and that's it. So that is our John object. And we can now, just to take a look at how it looks in the console, just log it. Okay, and so here we go. So this is our object. We can open it up and take a look at the different properties. So as I mentioned, these are all the properties of the John object. And so maybe now you're wondering how we can actually access them. And that's a good question. And it's very easy. All we have to do is to use the dot notation. So dot first name, for example. And the text editor already suggests us what name we can write here. And so let's try it out. And here we go, John. So all we have to do in order to read the value of the key of first name is to use the dot. Okay, and so first name is a property of John, and we read it by using the dot notation. All right, so that's one of the ways in which we can do it, but there's actually another one. So one is the dot notation, and so let me now show you another one, which is using the brackets. So just like retrieving an element from an array, we can also use the brackets to retrieve an element from the object, but instead of using a number, we use the key name. Okay, so let's say that we want the last name now, and we then have to actually put it in quotes. So basically we have to put a string here. So last name, and so now let's check it out, and here we go with Smith. Okay, so this is here a string, remember. And so actually we can do even better, not exactly better, but there's one thing that we can do, for example, is that we can declare a variable, and let's just call it x here for simplicity's sake. And then let's call it the birth year. Okay. And so now in here, and this has to be a string, of course. And now in here, we can use that variable. So we can say John X, and this X will then be birth year. And John birth year will be 1990. All right, so let's try that. And indeed, it worked. Okay. And this small trick here can be useful sometimes. And so that's why I showed it to you. Okay, so keep that in mind. Sometimes this might come in handy. So this is how you retrieve data from an object. And now we also want to mutate the object, so just like we did with arrays, and it actually works in the exact same way. All right, so what we can do now is to say john.job, for example, and we can set it to driver or to designer actually. Why not? So all we have to do is to say john.job, and then we can mutate the data, okay? And then of course we can also do it the other way around, so with the brackets notation, okay? So then our quotes and is married. And so let's set it to true now, okay? And so if we now log it to the console, then you will see that it should be different. Here we go, and so, here we go. So job is now designer, and is married is now true, okay? And so we can use the dot notation not only to access it like we did before, like here, but we can also do it to change the data, to mutate some of these properties, okay? And the same here with the brackets notation. All right, and now just to finish, we had two different ways of initializing a new array, right? So to create a new array, and the same happens with object. So we can do an object for Jane, and just like before, we can say new object. So in the array lecture, we said new array, and now we can say new object in order to create a new empty object. And now we can just fill it up with some data here. Jane.name, Jane.birth year, and just one more. So Jane, and this time I'm going to use the brackets again. And so we can say now last name also. Okay, this one let's call first name. And now we can log it to the console. Okay, so just so you see that it's going to work in the exact same name. And here we have an error, so you see last name is not defined, and that's because it's not a string, which is should be. So let's try that again, and so it looks the exact same way as before. So again, it works just like the object literal. Let's actually write that down here. So object literal is a way of defining objects using this syntax here, so just with the curly braces. And then down here, we have the new object syntax. Okay, so that's the very basics of objects and properties. So in this lecture, we talked about properties, and the next one, we are going to talk about methods, which is also something very important related to objects. So stay tuned for that one. Let's continue learning about objects, this time diving deeper into object methods. So we learned in the last lecture that an object can hold different types of data, right? So including arrays and even other objects. But we can also even attach functions to objects. And these functions are then called methods. So let's see why and how we can create methods. And for that, let's actually go back and grab our John object, so we don't have to rewrite it all again. Okay, and so here we have our object. So what we want to do here is to add a function, so a method, to this John object in order to calculate the age of John. So we don't want to have the age hard-coded in the object because it changes every year. And what stays constant, of course, is the year. And so instead of having the age hard-coded here in the object, we have a function that calculates that age. So all we have to do is to basically define another key. So calc age, which stands for calculate, of course. So calc age, and now just like before, we define the value. And the value here is a function expression, basically. So we write function and then the birth year. All right, and that's it. Now all we have to do is to write our function body. And now maybe it makes a bit more sense why we learned about function expressions and function declarations before. So this here is clearly a function expression, right? So it's like we have a function without a name, just with the argument, which we then assign to a variable, which is in this case, this calc age. And so this function here is now a method of John, okay? So now all we have to do is to return the year, just like we did before, minus the birth year. Okay, simple, right? Now, how do you think we are going to call this? Well, it's very simple again. And let's console log the result of calling that function. And so the way we call it is just the same way that we access properties. So John and then dot. And instead of accessing one of the properties, we simply access calc_age. And then it's just a normal function call. So calc_age, and then we pass in the year. So 1990 in this example. And so now we will get the age, which is 28. Great. So that is the very basic functionality of methods. And remember that in the array lecture, I showed you methods for an array. And so that means that arrays are actually also objects, right? Because that's the only way that they can have methods, right? Because only objects have methods. So arrays have all these functions to change them, like push and pop, remember? We will dive deeper into why things work like this and how we can create this same functionality for our objects later in the course, okay? For now, we're just talking about the method basics. So just to learn how methods really work. Now, continuing with our John example here, I'm sure that you noticed that the year of birth of 1990, this one here that we passed in as an argument of the function, is actually already defined in the John object itself, right? So it's already here, in fact. So what if instead of having to pass it into this function here again, we could access that property right from this method inside this object? Well, it turns out that we can. And that's because in every object, JavaScript gives us a special keyword called this. Okay, and so let's try that out. And so instead of having to pass in the birth year, which is already defined here, we can say this dot birth year. Okay, so this, what it means here in this context is John. So this means this object, the present, the current object. Okay, and so when we call this method here, this dot birth year will mean John.birth year. All right, so let's try that out again. And let's just change it here so that our output here is going to change. So let's put 92 here now. And if we reload, well, you see that he's not 26. And what that means is that this actually works. So we can access now this dot birthday because this, again, means simply the current object. So basically the object on which we have calc_age. Okay, so that's great. But let's actually take it even one step further. So what if we actually wanted to store this result right into the John object? Well, we could do it like this. So we would first calculate the age. So just like this, and then we would say John.age equals the age, right? Or we could actually do it all in one line. So something like this. Okay, so we call John.calcAge, which will return the age, and then we set John.age to that result, right? So remember that we can set properties like this, just as we learned in the last lecture, right? But we actually can do even better. So if we can access a property in the current object like this here, well, then it means that we can also set it, right? And so instead of returning this number here, we can simply say this dot age should be equal to 2018 minus this dot birth year. Okay, and so now all we have to do is to call this function, right? Then we can also log the entire object to the console just to see if the result is really there. And let's see, and indeed, here we have the age of 26. And so this worked. So the this keyword is something really powerful and really important that you will have to master throughout your journey of learning JavaScript. So remember, in this lecture, we went from actually having to pass in the birth year as an argument to the function to being able to read the birth year directly from the John object using the this. And then from there, we went even one step further, and instead of returning the age result, we also stored it right into the object. And so that's the best we can do, and that's the way it's supposed to be working, all right? So if you understand this basic functionality of methods and this keyword, then you're well on your way on mastering objects later in this course, okay? Because this is actually a very complex subject, and we will dive much, much deeper into it later in the course. But for now, I really just want you to understand that an object has a special this keyword, which basically points to itself. And I want you to understand that you can use methods like this. So just like I showed you in this video. All right, makes sense? So I think you're now ready for yet another coding challenge. I hope that you like these. I think they're perfect for you to practice your skills and what you just learned. So hopefully I see you there in a second. It's coding challenge time again. So here we go. And let's remember the first coding challenge where Mark and John compared their body mass indexes. So let's now implement the same functionality, but this time with objects and methods. So for each of them, create an object with properties for their full name, mass, and height. Then add a method to each object to calculate the BMI. And what I want you to do here is to both save the BMI to the object and also return it from the method. And then in the end, I want you to log to the console who has the highest BMI together with the full name and the respective BMI value. All right? And again, don't forget that they actually might have the same BMI. And if you don't remember the formula for calculating the body mass index, then it's down here again. And you can also go back to the other challenge and find the solution there. Just keep in mind that the mass has to be in kilogram and the height in meter. Okay, so this again is using the knowledge that we just learned in the last 2 lectures. So I think this is a fun way for you to retain that knowledge immediately. Okay, so good luck and see you once you're finished. So did you manage to successfully complete the challenge? Well, here is the way that I did it. So I'm going to start by creating the John object with the object literal syntax. And let's give it some more space down here. All right. So then the full name property will be John Smith. Then the mass is 92 kilograms. And the height is 1 meter and 95 centimeters. So 195. And then we need to calculate BMI method. So this is the trickier part, right? But it's still not really difficult. Okay, so we use a function without any argument, and that's because we're going to read the mass and the height both from the current object, right? And so how are we going to do this? Well, the formula is this dot mass, okay, divided by this dot height times this dot height. So the height squared. Okay, so remember that this here means the current object. So it will read the mass from the current John object. And so the mass here will be 92. And then the same here for this dot height, and of course this here as well. So here it will be 1.95 times 1.95. And where do we want to store this result? Well, it should be in this dot BMI. So remember, we can not only read properties from the object using this, we can also set them. And so here we set this dot BMI should be result of this formula. Okay, and so that's actually it. So we calculate the BMI, and then remember that here from the text that we should also return it. So save the BMI to the object and also return it from the method. And so return this dot BMI. Okay, so that's John, and now I'm just going to go ahead and copy it for Mark, because the method is actually going to be exactly the same, obviously. Okay, so it's going to have no difference. The formula and everything works just the exact same way, and so we have the exact same method on the Mark object. Here it's Mark Miller, then the mass is just 78, and the height is 1.69. Okay, and as I mentioned, the rest stays the same. So we're now ready to calculate the BMI for both of them. So John.calc BMI, remember that's how we call methods, and then the same for Mark. Okay, and so yeah, let's take a look at these 2 objects actually. So console.log both John and Mark. So we want to get both of these objects here into our console. So here they are. And we see that both of them now have the BMI. So John has a 24 and Mark has a 27. So great. So you see that it's actually very nice to have a method directly attached to the object, because this function is really related to this object, to this person in this case. And so it makes sense that we can have the method really together with the data instead of having an external function which could do these calculations as well. Okay, so that's why we make use of this pattern, let's say this best practice, to have the methods inside of the object. Now you're probably thinking that having the exact same method on these two objects kind of violates the dry principle that I showed you before, so the don't repeat yourself principle. And that's actually correct. So this is not the perfect way of doing it, but for now, with the knowledge that we have at this point, this is the best that we can do. Later in a more advanced section of the course, I'm then going to teach you how we can have the exact same method on multiple objects without having to repeat the code. But for now, this is more than okay like this, okay? So finally, we have to log to the console. So what do we want to say? Who has the highest BMI together with the full name and the respective. Don't forget they might be like a draw, so the same BMI. And so we've done this many times before. So John.BMI, let's now read it here from the object. If it's greater than Mark.BMI, well, then let's log to the console that John.first name, or actually its full name, has a higher BMI of, and then John.BMI to read it again. All right, now an else if here, because there can be the case where they both have the same, and so we have to account for that as well. So now it's Mark.BMI is larger than John.BMI. And then let's just grab this piece here of code, paste it here. This should be Mark and this one as well. And then just the else in case it is the same. They have the same BMI. Okay, so according to our data, Mark Miller has the highest BMI, and indeed that's exactly what we log to the console. So Mark has 27, as you can see here, and John has a 24. So let's now increase John's mass here to, let's say, 110. And so now, indeed, he has the larger BMI of both. So that's already almost perfect, but we can do even better. Okay, so let's get first rid of this. And what we can do is to actually calculate the BMIs right here. So we calculate the BMIs using the call BMI function, of course, or the method, I should say, and then we use that data to take these decisions here. But keep in mind that these methods, they actually also return the BMI, right? And so we could replace John.BMI here by the method call. And so let's actually do that. So I'm going to copy it, or actually cut it from here and paste it down here, and the same for Mark. All right, so does that make sense to you? So again, we know that this calc.BMI method here will return the BMI itself. So we have it here. So return this.BMI. And so down here, we will calculate the BMI and then immediately return it. And it will then be put here in this logical comparison, right? And the same, of course, for Mark. So in this case, this here will then be replaced with 27.3, okay, which is what we see here. And this John.calc.BMI will be 28.9, right? So this value here. And then the comparison can happen and then everything can just work the same, okay? And so we don't need these additional lines where we first calculate the BMI and only then we read it. So we can basically calculate it and read it at the same time here. All right, and here then we can read it already because at this point it is already calculated. And so of course we're not going to call BMI method again. So we only want to call it once, and then from there on we can just directly read the value from the object. So we're not going to put calc.BMI here or here because at this point again it is already calculated. Okay, does that make sense to you? And of course again you wouldn't have to do it this way. So it's not really important, but that's actually the reason why I asked you to also return the values here from the methods, so that we can then use this little trick where we can calculate and compare the values here all in one tag. All right, and just to confirm that it works the same, of course, here we go with the correct solution. Great, so we're almost at the end of the section. There's just one more thing to learn, which is loops and iteration. And so that's exactly what we're going to do in the next video. So I hope you enjoyed this one, and so see you next time. So we're almost finished with the basics of JavaScript, but there's still one thing missing that's crucial to programming in general, and that is loops. So in the lecture where I first introduced you to the if-else statement, I mentioned that it was just one of many control structures. And so here are some more control structures: loops. So loops are a very important aspect of any programming language. Just imagine that you have a very repetitive task. Instead of writing, like, for example, 10 lines of the same code, you would just use a loop. So we can basically automate repetitive tasks using loops. Okay, and there are different types of loops in JavaScript, and we will start with a simple for loop. So suppose we needed to print the numbers from 0 to 9. Okay, so something like console.log and then 1. And then 2, 3, 4, 5, and so on and so forth. So you would have to do this 10 times, but that's not a good idea at all, right? And so instead, again, we use a loop. And I'm going to start with a for loop. So we write for, and then the for loop has 3 parts. It has the initial value of a counter, a condition that is evaluated before each loop iteration, and finally a counter update after each iteration. Okay, so let's go through them one by one. So the first part is the initial value of a counter. So imagine that we want to print from 0 to 9. Okay, and so we start at 0. And so we define a variable called I, for example, and set it to 0. And I use I here because I is kind of a standard in JavaScript for a counter variable. Okay, so this is the variable that will be updated in every loop. Okay, then we use the semicolon. And now the second part. So this is a condition that is evaluated before each loop iteration in order to see if the next loop should still be executed. So if we want to count from 0 to 9, well, then our condition will be that I should be less than 10. Okay, so only if this turns out to be true, then the next loop will actually run. Okay, so in the beginning we start with 0, and so I will be 0, and 0 is less than 10. And so it's true, and so the loop will start. All right? And then next up, and finally, we have the counter update after each iteration. So if we want to count from 0 to 9, like 0, 1, 2, 3, 4, 5, all the numbers, then in each iteration, we want to increase I by 1. Okay? And remember a special operator to do that. It is the plus plus. Okay? So this is the same as writing I equals I plus 1. Remember that? Okay, and then in here we have basically the loop block. So what should happen in each of the loops? And in this small example, all we want to do is to really log these numbers to the console. So console.log I. And so that's it. That's really it. Let's take a look. And so now here you see all of these 10 numbers from 0 to 9. All right, so let's go through it again and see why this works. So I'm adding a comment here and try to write out what happens in each iteration. So we start and I will be 0, right? Then the condition is evaluated, and so 0 is of course less than 10, and so that's true. And so we will then log I to the console. So log I to console. And then finally at the end, the counter is updated. Okay, and so I plus plus. Okay, then in the next iteration, we will have I is already 1 at this point, right? And so the test is now I less than 10, which is still true. And so the next iteration will start. And so again, we log I to the console, and then I will be incremented by 1. So we do that a couple of times until we reach the end. Okay, so let's actually copy this here, And again, this is just to show you how this works. So this happens a couple of times until we're at a point where I is 9 already. And here I wanted actually the less symbol. Okay, and so at this point we are at 9, and 9 is still less than 10, and so it's true. Then we log the I to the console, and I gets incremented just like before. Okay, but then it means that at the next step we are at 10. And so 10 less than 10 is now false. And so we enter the loop. We exit the loop, which means that the loop finishes and it no longer continues working. Okay, and so that's why we stop at 9. All right, does that make sense? Now we could of course change some stuff here. So imagine that we wanted to count until 20. So we can put 20. Actually, this will go until 19. Or imagine that we wanted to really start from 0 and include the 20. So we want to start from 1, not 0, sorry. So starting from 1, and we wanted to include the 20. So we can say less or equal, right? And so in this case, this will only fail as soon as I is 21. And so we start at 1 and go all the way to 20. And we can also add like a step here. So instead of simply adding 1, we can add 2 in each iteration. So let's try that. So instead of doing I++, we can do I plus equal 2. Okay, and remember, that's the same as writing I equals I plus 2. Let's check it now. And so indeed, it works. So we start with 1, right? And then we increase the counter by 2. And so the next one will be 3. Right? And then 5, and so on and so forth, all the way to 19. And 20 is not included because 19 plus 2 is already 21, which is, of course, greater than 20. All right, so that is the very basic functionality of the for loop. Now let's look at a bit more practical example. So let's say that we have an array here, and let's actually copy the array from the array lecture here. And where is it? So yeah, this one is the one that I mean, so the John array, instead of having to write it out all over again. So we have a couple of data here about John. So let's say that we have an app where we need to display these 5 values here to the console. Well, maybe not to the console, but to the user interface, but we're just working with the console here. And so let's pretend that we need to log these 5 values here to the console. And so of course, just like before, we could do it like this. So John 0, and then like all the way to 5, actually to 4, right? So we could do it like this, right? So that would solve the problem, but not in a good way. So imagine that we had actually 50 elements in this array and not just 5. So what would you do then? You couldn't just create 50 lines of the same code. And so of course, the solution here is to use a loop. So let's get rid of this here and instead write it as a loop. So again, a for loop. So var I equals 0. And why do we start at 0? Well, we start at 0 because the array is 0 based. And what we want to use the counter here is to read the element of the array at position 0, 1, 2, 3, and 4. All right, so we start at 0, and we want the loop to run as long as I is less than the length of the array. Okay, and why is that? Well, it's because the length of this array is 5, and so as long as the counter is below 5, so 0, 1, 2, 3, or 4, we can then read the data out of this array. But starting at 5, there's no more data in the array. So there's nothing at position 5 in the John array, and so at 5, we no longer want to read anything. So remember how we can read the length of an array, so the number of elements? Well, all we have to do is to use the length property. Okay, and then we want to read all of them, and so we do plus plus just like before. All right, so this here will maybe not make 100% sense to you, but it will after you see exactly what we're going to do here in the block of this loop. Okay, so what we're going to do is to log to the console John at position I. Okay, so instead of writing out 0, 1, 2, 3, and 4, we let the loop take care of basically putting the numbers here. So in the first one, it will be 0, and then 1, and then 2, and then 3, and then 4. But not 5, because John.length is 5, and this loop only runs as long as the counter is less than 5 in this case. Okay, so let's test it out. And yeah, here we go. So all of these 5 logs are now coming from line 597, so this line here. So does this logic here make sense to you? Just to make sure, let's do it again. So we need this counter variable here, I, in order to log to the console John 0, 1, 2, 3, and 4. So we want all of these 5 elements to be logged to the console. And instead of having to write out John 1, John 2, John 3, John 4, and John 5, we just use this loop. And so we start at 0 because that's the first element in our array. After each iteration of the array, we increase the counter value by 1 because we want to read all of the 5 values. And finally, we run this loop as long as the counter variable is still smaller than the total length of the array, which is 5. So it will run for 0, for 2, for 3, for 4, but no longer for 5, because there's nothing at position 5. And we could, of course, manually have put it here with a 5, but then imagine that we would add something here. So something like blue as a favorite color, and well, then it would not dynamically change the array. So if we now reload it, it would not display the blue here to the console. But instead, if we go back and put it to John.length, well, then it will automatically figure out the length and then loop through the entire array. Because now John.length is 6, and so it will also loop the element number 5 of the array. So indeed, now it appeared down here, the blue as well. Okay, so I hope that now it's crystal clear to you. And looping through arrays is actually one of the biggest use cases for loop. So this one is really important to understand. Now there are actually even better ways and also simpler ways of achieving it without using this specific for loop. But once more, let's talk about that a bit later, because that's a bit more of a complex topic. And for now, we're just really looking at the fundamentals. So that was the for loop, but there's also another type of loop in JavaScript, and that's the simple while loop. So let's try to replicate the same functionality here with the while loop. So the difference between the for and the while is that in while we only have the condition. So all we have to pass into the while loop is really this part. So we can say that while I is less than John.length, then it should keep executing this code. Okay, so basically this logging functionality here. And so if you want to have the exact same functionality as with the for loop here, we first would have to start by defining the variable out here. So I equals 0, and then at the end of each loop, we will have to increment I. Okay, and so that's actually it. So this here is now the exact same thing as this for loop here. But of course, it's much easier to just use the for loop here. Okay, I just wanted to let you know that there's also a way of doing it with the while loop. So let's add some comments here. So this is the while loop, and well, this here is the for loop. All right, and now I just want to show you the continue and the break statements. So we use the break statement in order to break out of a loop, and we use continue in order to quit the current iteration of the loop and continue with the next one. Okay, so let's just take a look at a couple of quick examples. And I think I didn't even show you the result of this one. So just to make sure, and now it is, well, now we have all of this here, but you see that it's just the same. So we have these 6 here coming from the for loop, and we have these 6 here coming from the while loop at line 604, right? And so in fact, it works just the same way. Now let's actually get rid of these here. Not really get rid, but I'm just going to comment them out so that they're not getting in my way for the next part. All right, so let's copy this here so that I can now show you the continue and the break statements. And let's start with the continue. So again, the continue, we use it to quit just the current iteration of the loop and then continue right to the next one, okay? So let's say, for example, that we only wanted to log elements that are strings. Okay, and so we can implement a logic that will do it so that if it's not a string, it will quit the current iteration and then continue with the next one. All right, so how do we check if it is actually a string? Well, remember the type of operator that we used right in the beginning of this section. So we can now say type of, and I think I misspelled that, so type of John at the current position. So if this one is different from a string, and I think we haven't used different up until this point. So we only ever used the equal, but now I don't want equal, I want different. And different, we use the exclamation mark like this. So this here is the strict different operator. And just like with the triple and the double equals, here we also have the normal different operator and then the strict different operator like this. And just like with the equality, we should always use this one. Here we always should use this one. So exclamation mark and then equal equal. Okay, and so this means different. So what we want to do here is that each time that the type of the current element is different from a string, well, we just want to continue. Okay, and I think this is also something new. I think that up until this point, we always did the if like this. So we had this block and then, well, kind of the text in there, just like this, okay? But if it's only like on one line and just a simple if statement like this, we can actually do it in one line without the curly braces and just write it like this. So if this, then continue. And so this will then break out of the loop and will continue to the next one. So for example, when we hit Smith here, then the type of John I will be string. And string is not different from string, right? And so we will not continue. Instead, we will go straight to this line. But in the next iteration, when it's 1990, well, that is then different from a string. And so therefore, we will enter the if part here, and we will then continue. And so this line here will not even get executed. All right, so let me show that to you. And indeed, we now only have John Smith, designer, and blue. It skipped the 1990 and also the false. And again, that's because the type of these two is different than string. So different here, different than string. All right, so that is continue. And now let's do something similar for break. But the difference with break is that it exits the current iteration and the entire loop as well. So it doesn't continue to the next iteration, all right? And so now this time, let's say that we only want to print until we encounter something that is different from a string. Okay, so as soon as we hit something that is not a string, we will not print anything else, all right? Let's simply replace this one here with break. Well, I could have just done it up here, but yeah, so this way we have both versions, all right? I'm just going to, I'm going to leave it like this. So let's now reload. And you see that these four here are from the other loop, so from line 615, and now from line 620, which is this one here, we only have John and Smith. Okay, and so that's exactly what we were looking for. So it prints this string, then this string, and then it encounters something that is not a string, and so it breaks out of the loop and doesn't print anything else from there. Okay, so that is how continue and break work. I hope that makes sense to you, okay? All right, and now just to finish, I want to give you a small challenge. Imagine that we wanted to loop through the John array here, so this one here, the other way around. So starting from blue, then false, designer, and then all the way to John. So how can we solve that? How can we loop through the array the other way around using a for loop? So do you think you can solve that? You can try to pause the video here and give it a second and try it out for yourself, okay? So did you figure it out? So let's add a comment here before we do it. Looping backwards. And really all we have to do here is to think where we want our counter to start, what the condition should be, and what we want to happen with the counter variable. So starting with I, what do we want I to be in the beginning? Well, we have this John array, give it some space here, and we have 6 elements in here, 0, 1, 2, 3, 4, and 5. All right, and we want to start at element number 5, right? And so what is this 5? Well, it's just the length of this entire array minus 1. Okay, and so let's write exactly that. John dot length minus 1. Okay, and that will be 5 in this case. Then how long do we want this array to run? Well, we want the array to run until I hits 0, right? So the last one that we want to print is the first element of the array, which is 0, okay? And so I should always be greater or equal to 0. So greater or equal to 0. Make sense? So remember that whenever this here turns out to be true, then the next loop will be executed. And so what we want here is it to be executed whenever I is larger than 0. Okay? Because now what we will do here after each iteration is to actually decrease the counter. Okay? Make sense? So we start at 5, and then after each iteration we decrease the counter. So 5, 4, 3, 2, 1, 0. And at 0 it will still work because I is greater or equal to 0. But then after that it will hit minus 1, and then the condition will no longer be true, and then it will stop working. Then all we have to do is to, of course, log it, and this is always the same part. And so let's now give it a try. And so these here are our results starting here. So all of these come from line 627, so this one. And so you see that in fact it is really looping it backwards. So it starts from blue, false, designer 1990, Smith, and John, which is number 0. Okay, so I hope that made sense to you. This was just a small exercise for you to think about these 3 parts here of the for loop and how we can achieve a different functionality than this simple one that I explained to you before. Okay, and so now it's time for yet another challenge, and this will be the last one for this section using all of the stuff that we learned throughout all of these videos. So you have come a long way up until this point. Congratulations. And I hope to see you in the next challenge, because I think it's really important that you take these and try it out on your own. Welcome back to the last and most exciting coding challenge of this section. So remember the tip calculator that we created in another challenge? Let's now create a more advanced version using everything that we learned up until this point. So this time, John and his family went to 5 different restaurants, and the bills were $124, $48, $268, $180, and $42. And again, John likes to tip 20% of the bill when it is less than $50, 50% if it's between $50 and $200, and 10% if the bill is more than $200. All right, so implement a tip calculator using objects and loops this time. So here are the steps for doing that in order to help you. So first, create an object with an array for the bill values. Then add a method to calculate the tip, and this method should of course include a loop to iterate over all the paid bills and to do the tip calculations. Then as an output, you should again create 2 arrays, one containing all the paid tips and 2 containing all the final paid amounts. So again, the bill plus the tip. All right. And a hint that I have to give you here is that you can start with 2 empty arrays as properties and then fill them up in the loop. Okay, so an empty array is just like this here, and you can start with 2 empty arrays, one for this number 1, so all the tips, and then 2 for all the final paid amounts. So start with these 2 as empty arrays, and then in the loop you can fill them up. All right, so that is already a lot of work. But after that, I even have like a step 2 for you. So to even take it to the next level. And that is that Mark's family also went on a holiday, and they are going to 4 different restaurants. And the bill that they paid were $77, $375, $110, and $45. And Mark has a slightly different rules when it comes to tipping. So he likes to tip 20% if the bill is less than $100, 10% when the bill is between $100 and $300, and 25% if the bill is more than $300. Okay, so again, that doesn't make much sense maybe, but that's just, again, to make it a bit more exciting and to make these 2 tipping functions different for each of the persons. Okay, so I want you to implement the same functionality as before, but this time, of course, using Mark's tipping rules. Then create a function. And I don't mean a method, so like an outside function, to calculate the average of a given array of tips. And here I have to give you another hint. because up until this point, we never did anything like this. Okay, and so I give you a hint here to calculate the average, and that is that you should loop over the array and in each iteration store the current sum in a variable which starts from 0. Then after you have the sum of the array, then you simply divide it by the number of elements in it. Okay, so that's the formula for calculating averages. So if that's a bit too difficult for you, then you can just stop maybe after 0.5. Okay, but I would like you to try out to calculate the average. All right, so that's here on number 7. So you use the function that you created in number 6 to actually calculate the average for both families. And then you log to the console which family paid the highest tips on average. All right, so again, this one is a bit tricky maybe. So you can, no problem, take an hour or even more to try to accomplish this. All right, I think it's really important for your learning process to go through something like this, a bit more difficult even, so that you really have to try instead of it being super easy, because then you don't really learn anything, okay? So take an hour or something like that to really go through this and really try to solve these problems, all right? You don't need to be fast. Then if there's some parts that you cannot figure out, again, no problem, you can just check out my solution in the next video. All right, here goes my solution for the first part of the coding challenge that I just showed you. So I start with creating the John object. So the object literal again, then the full name, John Smith, and then an array of the builds, just as it says in the instructions. And the builds are 124, 48, 268, 180, and $42. Okay, and that's all the data that we need. Now we're already ready to write our calc tips function, or method, I should say. So function without any argument, such like before. And so this challenge here is actually a bit similar to the one before, where we calculated the BMIs for John and Mark. The only difference is that this time we also need some loops. And so that adds a new level of complexity to this function here. All right. So remember how I said that you should start with an empty array for both the tips and the final values. And while you could do that, you could do it like this. So tips, and then here an empty array. But I figured that it would be a bit cleaner to start without it here. And instead, as soon as we run the function, then we add these empty arrays to our object. Okay, so how do we do that? Well, we just say this dot tips equals an empty array. And then also this dot final values is also an empty array. Okay, so I'm giving it the same names as I did in the other tip calculator. So tips will be the array with all of the 5 tips. So one for each of these builds, and then the final values is the array where we will have the sum of each tip with each bill. Okay, and so now we have to loop through the builds in order to calculate the tip for each of these values. Okay, and so of course we're going to use the for loop, such as we learned in the last lecture. For, and we're starting at I, 0, and we're going until I reaches the length of the bills array. So once more, it's the exact same thing as we did in the last lecture, okay? So we're just applying what we just learned before. So where is this builds? Well, it's at this dot bills and then dot length. And so here you see something for the first time, which is 2 dots, okay? And actually the dot is an operator. So let's go to our operator precedence table that is still opened here. And here you have this operator, which is called the member access. Okay, and we see that this one is executed from left to right. All right, and so this is why this works. So here is the first one, so the first dot, and so this dot builds is the first part that will be executed. And so this here will be basically replaced with this array. And so we end up having this array here, and then after that we read then the length property, this one here, of that array. Okay, so if it was the other way around, if we started reading this way here, then it wouldn't work at all, because bills.length would be something unknown. So it wouldn't exist, because all that exists is this dot bills. And so of course it makes a lot of sense that we start basically reading, that we start executing from left to right. So that was just a small detail, but I think it's important to really understand why these things actually work the way they do. Okay, I hope you agree with that. So I++. All right, makes sense. So again, we're going all the way until we reach the length of the builds array, which is 6 in this case. So we execute it for 0, 1, 2, 3, and 4. Okay, so the length is not 6, it's 5. I think I said 6, but of course it's 5. All right, so what are we going to do in each iteration? Well, just like before, we are going to determine the percentage based on the tipping rules. Okay, so let's write that down here. Okay, and so I like to add these comments here in order to figure out beforehand, before actually writing the code. So we determine the percentage and then we add the result to the corresponding arrays. So this is the same stuff that we did before. So we defined the percentage without actually specifying it. So we just declare the variable here, but do not define it. And we do that based on the bill. So if the bill is less than 50, remember? So that's the rule that we have up here. So if the bill is less than 50, then the tip is 20%. It is 15% if it's between $50 and $200, and it's 10% if it's more than $200. All right, and so we are going to translate that here into code. Okay, and actually bill is not something that we have defined. So sorry for that. So it's not bill, but instead, what do we have here? We have this dot builds at the current position. Okay, so maybe this is starting to become a bit confusing. Okay, and I totally get that. And as I actually mentioned before, that was kind of the goal of this challenge, not to be confusing to you, but to make you think a little bit about how these things work. So how can we solve this kind of problems? Okay, so this dot builds is our array with the builds, right? And what we do here with the loop is to loop exactly through that array. And so it only makes sense that we then access the current position of this array using the current counter variable. Okay, and that's always I, just as we learned in the last lecture. All right, and so let's now define the percentage for this bill value, and that will be 0.2. Okay, so 20%. Then else, and let's actually grab this one here. So if it is larger or equal 50, and at the same time, it should be less than 200, right? So that it stays exactly between 50 and 200. So in this case, the percentage is going to be 0.15. And then finally, in all other cases, the percentage is going to be 0.1. Okay, now as you see here, we have a lot of duplicate code here. So this this.builds and then at position I, we have repeated it here 3 times. And so let's actually create a separate variable for that. So let's call that one bill. Okay, and so before doing anything here, we simply create a variable where we store the current bill value. All right, and so we can now go ahead and replace all of these here. And so that's a bit better. So instead of repeating the same code multiple times, we just store the value in a variable. Okay, so that is much better. Okay, so for each of the builds, we have now figured out the percentage. So all we have to do now is to add it to the tips and to the final values array. So this dot tips at the current position, and remember that is I. Well, and now it's very simple. It's the bill variable that we defined before. So this dot builds at the current position times the percentage. And so this part here is exactly the same as in the more simple version of our tip calculator, right? And now finally, this dot final values at the current position will be the bill plus the this dot tips at the current position. Or actually we can do this one here, so it's the same. Okay, so we have the bill plus the bill times the percentage. All right, and so that's actually it. So that is our tips calculator, which will at the same time calculate the tips for all of the 5 builds. All right, so let's actually try that out. So john.calc tips, and then let's log it to the console. Console.log John. All right. Oh, we have some syntax error here at line 674. So where is that? And indeed, I'm missing the if here, so else if. Probably you already saw that one coming, so I'm sorry for that mistake. And so now we have the object here, and in here we have our builds, we have our final values, and we have our tips. So it's all here now, okay? So we have 18.6, 9.6, 26.8, 27, and 8.4. And these, if we add it to this builds, will then result in this final values that we have here. So for example, this 180 plus the 27 is 207, and that's exactly what we see here, right? So it means that it's actually working. So the first part of the challenge is completed, I think. Let's take a look. So add the method, then should include a loop, add as an output, create these 2 arrays. Okay, so the first part is finished. Let's take a look at it again, because it's quite a lot of code here, and this is by far the most complicated code that we have written up until this point in the course. So the hardest part probably to grasp is the fact that inside of this method here, this calc tips method, we have this loop that calculates all of the 5 tips all basically at the same time, or one after the other, but automatically. So that's exactly the reason why we used the loop, okay? And so we had to have these kind of confusing like this.builds.length, where we first read the builds array from the current object, and then from there we get the length, all right? And then here we get the current bill, so the current value, and from there, well, basically the same is then the rest is the same as we did in the other challenge, okay? Then another particularity was that we had to create these empty arrays here so that we can then fill them up. And maybe you thought that we could do it like this. So this.tips is equals this.final values is equals an empty array. So maybe you try to do it all in one line, but that is not going to work. So this here will not work, because what this is going to mean is that these 2 arrays will be the same. So in this case, if you did it like this, if you then added something to the tips array, so this one here, then you would automatically also add it to the final values, because they would be in fact the same array, all right? And don't worry if that sounds a bit confusing to you at this point, because later on, again, we will learn why it is that way. So what I want you to do now is, after this video, take a deep look again at this method here, and especially, of course, at this method here, try to figure out why everything works the way that it does here, and only move on if it really makes sense to you. Okay, so this was the first part of the solution. Now in the next video, I will then solve this second part. Okay, so I'm leaving that for a different video so that you can first go over this again and make sure that you understand 100% what's going on here.